Hello viewers, my name is Dr. Tavla Buriro and I welcome you all to this course on ethical hacking. In this course, the idea is to learn the essential techniques and the fundamentals of ethical hacking and how to use them to protect ourselves and others from cyber threats. This is actually the purpose of this course. Ethical hacking, as you know, is the practice of testing the security of a network or a system with the approval of the organization. Ethical hackers use the same techniques as malicious hackers, but with the goal of finding and fixing vulnerabilities, not exploiting them. This is basically the basic difference between ethical hackers and malicious hackers. Ethical hackers, they just try to find and identify the vulnerabilities and bugs into the system without exploiting them. And then they just report those bugs and vulnerabilities to the corresponding organization. While malicious hackers, they would try to exploit those vulnerabilities or bugs, for example, in order to do malicious activities. So ethical hacking actually is important because it helps organizations prevent cyber attacks and protect their data, assets, and of course, most importantly, their reputation. Ethical hacking can also improve the security, awareness, and skill of the staff and users. Okay. So I know ethical hacking is challenging, but rewarding as well. Okay. For those who have the passion, those who have the skills, and those who have ethics to do it. Ethical hackers need to have a strong knowledge. Knowledge of what? To be from my perspective, they should have the knowledge of cybersecurity. They should have the knowledge of networking, programming, for example, and various hacking tools and methods. They also need to be creative, curious, and adaptable to different situations and systems, for example. So the main purpose of this goal, of this course actually, is to introduce you to these concepts, for example, to networking. Okay, in networking, you will be learning how to analyze network traffic and identify potential entry points, for example. In operating system part, for example, we will check how to exploit misconfigurations and vulnerabilities in Windows, in Mac, in Linux, for example. And in programming and in scripting, this is also a core skill that one must have for doing ethical hacking. Uh, Actually, this is how you automate tasks or scans for vulnerability testing using different languages. Information security, like I said, is extremely important. So we, as ethical hacker, we should know how to apply those principles regarding confidentiality, integrity, and availability for ethical hacking projects. Okay. So basically, let me issue a disclaimer. This course is designed for beginners, not for experts at this level. Okay. So this course is designed for beginners who want to learn ethical hacking from scratch. I don't want them to have a prior experience and knowledge to enroll, for example. However, they should have, for example, the basic understanding of computers, internet, and they should have the willingness to learn new things. I can assure you that by the end of this course, okay, you will be able to have basic understanding of the concepts and ethics of ethical hacking. You should be able to perform basic and advanced penetration testing on various systems and networks. You will be using different hacking tools and frameworks to conduct ethical hacking by yourself. Then you will be able to report and document your findings as well, and recommendations, of course. I would suggest to prepare for certification exam as well, like a CEH exam. So you will have to access. For example, I will try to share with you all the material, okay, and I will welcome your feedback, support, suggestions if you have any. So if you are ready to start your ethical hacking journey with me, subscribe to this channel and hit the bell icon to get notified, and let's get hacking now. Okay. So before jumping to the main topic, I explained you why it's studying ethical hacking. So Studying ethical hacking is extremely important these days. Okay, why? Because you see, uh, just to remind you, just to make sure that we are on the same page. Ethical hacking is actually the practice of testing and improving. What is improving? What are we going to improve? We are going to test the security of a system, and if there exists a bug or there exists a vulnerability, we are going to fix this, okay, not exploit it, and then we can document it and recommend the organization to do necessary steps. Okay, and actually, we will be simulating exactly the same way the attackers do. Okay. Now, why is it important? It is extremely important because, you know, if a successful malicious attack, for example, could lead to financial as well as sentimental consequences. Okay. So I I'm kind of interested in learning all these things. I want the new generation, for example, to understand all these concepts very, very well. And what you can get, for example, if you are learning ethical hacking. So in ethical hacking, you could take the line of penetration testing, for example, or you could participate to bug bounty programs by different organizations, for example. Okay, I will explain these bug bounty programs later. Cybersecurity research, for example, you would be interested in doing research in malware analysis domain or user authentication domain or any domain related to cybersecurity, for example. You would be these skills will be very, very important for you then. Cybersecurity education as well. If you need to teach a course related to cybersecurity, it would be really helpful to have those practical skills, for example. So I wrote here penetration testing. So if you are taking this line, for example, what is penetration testing? Penetration testing means these penetration into a system with authorized access. So you need to have a permission to do this penetration testing. Now, ethical hackers, they are bound to use unauthorized attacks, not unauthorized attacks, authorized attacks on a system or network to evaluate its security, using multiple tools. They use the same tools. We use the same tools like nmap, the harvester. We use, for information gathering, we will be using Shudan, Maltigo, for example. These are different tools that could be used for information gathering. We will be using the same tools. And then, for example, big bounty programs are there as well. And, you know, when you find a bug or a vulnerability in a program of a top-notch company, let's say Microsoft, for example, you earn a lot. So ethical hackers report these bugs and flaws, these vulnerabilities that they have found out, and they report these bugs and vulnerabilities to the developers or the owners of those organizations and receive rewards or recognition of their contribution. So, for example, here you see a lot of money is paid to the one who actually reports these bugs or vulnerabilities. Sorry. In fact, you see up to $100,000 or up to $60,000. So the idea is to make you understand all these things. How good you are at doing something. Then, for example, you will be able to have those skills and you will be able to participate into those bug bounty programs. So I would suggest you to go on this link, for example, microsoft.com/en and minus us/msrc/bounty. You will be able to see all the open bounties. Now, why studying ethical hacking? So this is actually the main part of this video. Why studying cybersecurity or ethical hacking? I would say cybersecurity for research and education. Like I said, if you are interested in continuing your education in for example, doing masters or PhD in cybersecurity related field, it's extremely important to have these skills. Okay, and also, like, since humans are considered the weakest link in cybersecurity, so it's really good to make them educated, for example, related to cybersecurity things, and they should be made aware about these problems. And of course, we need to, promote best practices of cybersecurity. Okay. For example, best practice of authentication, what it could be. We as a user should not be using simple passwords. We should be using complex passwords. Okay. So these are the best practices, for example. So ethical hackers actually they conduct experiments in the same way as malicious hackers do. Okay, and but they investigate and discover, for example, new threats, new techniques, and solutions for cybersecurity. Okay, this is like this point actually is extremely important. You can continue these points in your masters or in your PhD programs as well. Now, salaries, as far as salaries are concerned, for example, ethical hacking is a very good field, very, very good field. And for example, the salaries of entry level position is like Glassdoor reports $109,552 a year. So it's quite a lot salary, for example. But the salary depends also on the experience as well. More experience you get, more skills you have, for example, you get more salary. Okay. And also like by the, for example, having the basic knowledge of basic ethical hacking, for example, you can be inducted as a security engineer or cyber security consultant, for example. Their salaries are also like $106,000 or 97.259 dollars, for example, 97,000, for example. So the point is, this is an emerging area. Okay, lot of threats are being discovered these days. We have a lot of attack vectors coming in. So there will be a need of ethical hackers, cybersecurity experts, security engineers in this area. So I would suggest to pursue this career, for example, whether you are a bachelor in computer science, electronics, mathematics, I don't mind, but I would suggest you to go for cybersecurity domain like ethical hacking, for example, or take any line, for example, a roadmap for the cybersecurity, and you will be succeeding. Now, about me, if you are curious to know who am I, what am I doing, for example, a very short uh, slide, for example, I have a couple of slides to mention here. For example, as far as my education is concerned, before actually jumping to the education, I would just like to introduce myself. Like, I'm an engineer, I'm a scientist, and a researcher with extensive research in cybersecurity, especially in authentication and access control domain. So I'm working at a multidisciplinary area. So my area combines four different techniques, for example, four different domains: biometrics, machine learning, cybersecurity, and data science, for example. So I have to follow all these steps in order to complete my task. Now, as far as my education is concerned, I did bachelor's from one of the university in Pakistan back in 2007. Then I completed my master's in 2011. There is a gap of 10 years between these two degrees because I started working as communication engineer in one of the finest department in Pakistan. Then in 2012, I started here at University of Trento in this very beautiful building, my PhD, and I completed this PhD and defended successfully in 2017 with a major in security and privacy. Now, as far as my employment experience is concerned, I have been working since 2006. So since 2006, in 2006, I joined Pakistan Meteorological Department, which comes under the Ministry of Defense. I started working as communication engineer, and I stayed there till 2012 before leaving for my PhD at University of Trento. So I started my PhD in Trento in 2012 and completed in 2017, like I said earlier. And right after my defense, I got I won this position of postdoc, and I worked in the same lab with the same professor, and I continued for 2.5 years. In 2019, I switched to another university. I started doing postdoc again at University of Bolzano in Italy. And then in 2020, for example, I won this position of assistant professor, and I became assistant professor for 3 years. After 3 years, I moved to University of Ca' Foscari, Venezia, where I'm currently assistant professor in Department of Environmental and Informatics Statistics, okay, at Venezia. Now, I'm one of the organizers of Cyber Challenge 2023. So this is actually a national level Italian challenge in cybersecurity where we as organizers, for example, try to train our young generation, for example, and to participate to the national level and international level in the cybersecurity. This is capture the flag type challenge, for example, and teams from all over Italy they participate and do uh, they participate to this challenge of 6 months long. So about the course that I'm planning to deliver now, for example, is like ideally, since I'm not a YouTuber, a full-time YouTuber. I'm not. I'm a professor, so I have a lot of things to do, for example, but I cannot commit exactly 20 weeks, but I'm thinking that I will be able to get some time for of in 20 minutes 20 weeks, sorry, to on various topics of ethical hacker, to cover various topics of ethical hacking. And in these courses, for example, I will try to introduce at least 10 labs, okay, where the idea will be to run, modify, and understand all the examples that I teach, for example. So there will be 10 labs. Also, like if you would prefer, you could follow these two books that I'm suggesting. Otherwise, the material will be sufficient enough. Now, the syllabus, for example, like in the next, I have divided the course into the modules. The first module will be all about background, and in background, I will be discussing, for example, basics of networking, or like what are network topologies, what is actually a network consists of, which devices or equipments they are extremely important to construct a network, for example. Then we will discuss basics of cybersecurity, information security, like what is CIA triad, for example, why confidentiality, integrity, and availability, and why does they matter. Then I will try to set up a lab, and we will be checking those connected devices, for example, by different pings, by different protocols. Then we will do information gathering and reconnaissance, for example, and scanning and enumeration. So we will be doing all these things also like practically. So stay tuned with me, stay tuned with me. And one more thing, like these modules could or topics could be kept included as well. So we can add them later as well, should not be a problem. And so course duration, like I have said, like this time could be increased as well, so up to 30 or 25 based on the availability of time. I cannot commit full time here. And weekly schedule is like lectures and labs will be released every Sunday. So the first lecture you could expect on let's say 12th, okay, 12th of February. Session frequency will be, and the labs also. On Sunday, you will have lecture and a lab. And session frequency, for example, what I'm interested in, if you have any live questions, you could ask, questions in your in comments as well. But still, if you have any question, I'm planning to arrange a session every Friday, for example, of 30 minutes. Will when I will be live, you could ask as many questions as you want, for example. And the purpose basically of these sessions will be to answer your questions if you have any, and or to provide you any clarification sort of a thing, or addressing your concerns, for example. So I'm I'm excited to be here, and I hope you are also excited to join me for this journey. Next class will be on ethical hacking background. We will be covering, basics of networking, like what is a network, what are the network components, devices, how do we form network, for example. Then followed by a lab on packet tracer, for example. We could exploit packet tracer for creating a small network and try to analyze the communication between those devices. Then we will have TCP and UDP. We will discuss the difference between them. We will be discussing the difference between TCP and IP and MAC addresses as well. These are also very extremely important concepts. So I'm super excited to be here, and I hope you also. Until next time, thank you so much. Don't forget to follow, subscribe the channel, and hit the bell icon to get notified. Thank you so much. Bye for now.
Hello and welcome to our channel. Today, we're diving into the fascinating world of computer networking. Networking is the backbone of how computers communicate, and it's what makes the internet possible. We'll start by discussing MAC and IP addresses, the unique identifiers that ensure data gets to where it needs to go. Then we'll explore subnetting, a technique used to divide a network into smaller, more manageable pieces. Next, we'll compare TCP and UDP, two of the main protocols that govern how data is sent and received. We'll also talk about ports, which are like doors through which data enters and exits a computer. Finally, we'll walk through the OSI reference model, a conceptual framework that describes how different network protocols interact and work together. So, whether you're a seasoned IT professional or just curious about how your computer connects to the internet, we've got you covered. Let's get started.
Hello and welcome back to the Cyber Guardian Academy channel. Thank you for watching my content. I really appreciate that. Today we are going to cover, before jumping into the topic, I would like to remind you that this course is divided into different modules. And today I'm starting my first module, and in session 1 we are going to cover these topics. Okay, so there will be 3 more sessions in module 1, okay, covering other topics as well, like introduction to Linux, for example. Also, we will be creating a ethical hacking lab as well, and we will be covering some basics of information security. Okay, so this will be module 1, and then followed by other modules. We will discuss them in due course of time. Now, today I'm starting with the module 1 on session 1, and this is about background. Okay, background of what? Background of networking. Okay, so this module aims to cover, in order actually, basics of networks. What is basics of network? What am I going to cover in this topic? Okay, so we know that networks, for example, are everywhere around us. And what are they made for? They are made for enabling communication between devices. Which devices? Between computers, smartphones, servers, and many more. Okay, so they allow us to share resources and information seamlessly. So this is actually called network. Okay, then in the second topic, we will be covering IPs and MAC addresses. What are these IP and MAC addresses for? So every device actually which is connected on the network has a unique identifier. Okay, that unique identifier, for example, I call them IPs and MAC addresses. Okay, so these are unique identifiers. They are assigned on every machine or network interfaces. Okay, we will discuss them in detail. Don't worry if you don't get it now. So understanding these addresses actually is crucial for effective communication in this environment. Then we will cover subnetting, and for subnetting, for example, is actually the process of dividing larger network into smaller subnetworks. Okay, and I will tell you in detail why is it important, and how it helps us in optimizing networks performance and managing IP addresses allocation efficiently. Okay, we will cover these subnet masks. We will do some calculations. I will show you how, and also, like, I'm planning to give you a practical demonstration on a tracer, okay, to actually demystify this concept. Then we will have TCP and UDP. You know, TCP and UDP, these are two transport layer protocols, and they are very fundamental protocols used in network communication. Okay, so this TCP, it is called a transmission control protocol. It actually offers reliable connection-oriented communication, and UDP, user datagram protocol, it provides faster connectionless communication. We will also see them in detail in the next slides. In topic 5, we are going to cover ports and protocols. These are ports are like doorways, okay, that allow communication between devices over a network. So, and protocols, they use different ports for communication. So we need to understand, the relationship between these two. We will discuss popular protocols like HTTP, which is Hypertext Transfer Protocol, FTP, for example, File Transfer Protocol, and SMTP, which is a Simple Mail Transport Protocol or Transmission Protocol. And the ports they operate on, along with an overview of well-known ports. We will see them in the next slides. Now, and we will end our discussion, our topic or this video with OSI reference model. I will tell you what exactly OSI reference model is and why is it easier, for example, if we know how OSI reference model, for example, operates, it's easy for us to understand networking and communication in an easier way. Okay, so I'm excited. Let's jump in then. Now, we are starting basics of networking. As I told you, what is a network? Okay, so network actually is a world of interconnected devices. When I say interconnected devices, they could be, this interconnected devices could be routers, could be machines, computers, laptops, smartphones, for example. Okay, what are they connected for? What is the main reason? The main reason actually of their connectivity is to share the resources, to share the data among them. Okay, so the devices, as I said, could be anything. It could be server, it could be router, it could be switch, for example, printers, phones. We will discuss them in detail. So on this figure, if you see, for example, you see IP addresses. I very quickly, I want to show you this. If you see this router, for example, it has an IP address of 0.1, 192.168.0.1. Okay, so these are the IP addresses that I was talking about. And the medium of communication, for example, the medium of connectivity, for example, could be wireless and could be Wi-Fi. Okay, so they are connected on the Ethernet, for example, or they could be connected wirelessly. We will discuss them in detail in the next few slides. Okay, so next topic is like next question we ask ourselves, like what exactly is the size of a network, so networks are of many sizes. For example, a small home network, like at my home, for example, I have like 4 to 5 computers, 2 laptops, two mobile phones, for example, and very few devices, but in a home environment network scenario, so I call it like LAN, for example. Okay, and then these small networks could be in the same building, for example. Okay, and like which cover a small geographical area. I call it small networks. Okay, and then, for example, medium to large networks. If you have like for example, if you have a large building and every floor has a different LAN and you want to connect those LANs, for example, this will be medium to large network. And a metropolitan area network is example of large network. Okay, so and then is like worldwide web, where every WAN, okay, wide area network is connected to every other WAN. Okay, so like from the geographical area point of view, network could be of many sizes. Now, what is the purpose of creating networks? As I told you, the main purpose of creating a network is sharing of resources. Okay, consider you have a printer, for example, and you cannot give, if you are working in a large company or in a small company, even, for example, and there are 10 computers, okay, 10 people working in your environment, you would not be, giving all of those 10 a different printer, for example. So what would you do? You will share a printer among all those 10. So basically, the purpose of creating this network is the resource sharing. Here you see you have multiple servers, email server, you have web server, you have file server, for example. They are all connected to a switch. In the middle, you are seeing a switch. And then this switch is connected to the external router, for example, which takes you to the internet. So this is how we need to create networks, for example, for resource sharing. Then how to form the network? I told you, like for LAN, for example, if you connect two computers together, it's a LAN, local area network, okay? And I mean, the main point to remember here is if you are not involving any router in that particular connectivity, it's a LAN. Okay, and when you are connecting, when you are involving a router with and connecting it to the switch, for example, and it means you are connecting multiple local area networks. So this is how. This is what is depicted in this figure. So here you see, for example, I have an internet network of 4 routers. So these symbols, they are actually of routers. You see here, you have a LAN of devices where you could have a printer, for example, you could have a server, you could have any resource that you would like to share with LAN 2, for example. On LAN 2, you have multiple devices as well. So these are this switch is connected to these routers, for example, and if on LAN 1, also connected to routers. So this way, for example, these two LANs could communicate with each other. Okay. Now, network media, as I told you, networks could be connected, could be formed either via Ethernet cables, for example, or by wireless. Okay, so for Ethernet connectivity, for example, like copper is important. Okay, and there exists also fiber optics, another type of network media. Then you have wireless connectivity, like you said. So we need to have these network media used to create a network. Then we have some network representations, because packet tracer also in packet tracer we will be forming these networks by our own. So it's important to understand what is this figure is used for. So for example, on the desktop computer, if I could use, yeah, pick pen, for example. Just a second, sorry. So here, for example, you see if so this device, for example, okay, this device is a computer. You see, no, sorry, this one. This is computer. This one you will be watching it as well in packet tracer. It's laptop. This is printer, and this is iPhone, IP phone. This is wireless tablet and telepress pinpoint. So these are all endpoints that you will be watching in the next slides in the packet tracer as well. And there exist some intermediary devices as well. Like I told you, switch is extremely important device to form a LAN. You will be creating LANs with this LAN switch. Then you have for connectivity of LANs, you will be using router, for example. It could be a physical router. It could be a router with LAN, local area network, or it could be a Wi-Fi or wireless router. You will also have like firewall appliances, and then you will have a multi-layer switch as well. So these are called intermediary devices. You will be using them as well. Okay, so okay. Now, also like the network media, like you see here, for example, these are like wireless media. You will be using also, you can have LAN media as well. So this symbol, this line, for example, black line, it is used to represent LAN, local area network media. And this is WAN. It means you will be using this cable to connect to routers. Okay, we will be using them to connect the routers as well. We will see them later. Now, we how do we classify networks? Which kind of networks exist? Basically, we can we can classify them based on number one, size. Like I showed you a slide differentiating between local area network of a home, local area network of a large building, for example, and how they are connected. So based on the size, we can classify them. Based on the topology they are connected to, for example, like mesh, star, or bus topology. So what is the backbone of that connectivity? We can classify them accordingly using topology as well on the basis of the architecture as well. Okay, so we will be discussing these architectures also, like is it a client server architecture, means there is a like star topology, for example, so every client is talking to a server. Okay, that server is actually your main hub that is receiving all the communication from these aperture terminals. Peer to peer, for example, if it's a one-to-one communication, okay, we can classify them based on these architectures as well, and we can differentiate them, classify them based on the network technology as well, like intranet, for example. If it's a network of a particular company, it will be intranet, okay, or extranet, for example, or internet, okay. So this classification, what is the purpose of this classification? So this classification actually help us to understand the design, the performance, and the security of networks. Okay, and it plays a vital role. Now, just very quickly, if I could tell you, like based on the size, for example, we have different, you know, types of networks. For example, PAN, personal area network. Okay, so I can say like if my laptop and my phone are connected, for example, it's a personal area network using Bluetooth. For example, if I connect two devices together, it's a personal area network. Okay, in a very small geographical area. Okay, then you have local area network, which is LAN. So consider it as a network of devices within a limited area. So let's say in your apartment, in your home, for example, or office, or a campus, for example. Okay, small campus, and they could use like Ethernet, for example, or Wi-Fi. Okay, then you have metropolitan area network, MAN, for example, which is a network that connects multiple computers within a metropolitan area, within a city, for example, a large city. Okay, then you have wide area network. Okay, this wide area network is aimed to cover, has to cover, for example, large geographical area. Okay, in the world, for example, or such as a country. So we call this wide area network. So based on the sizes, you can differentiate now, and based on the size, just if I could show you this figure, for example, you see here these are three topologies: personal area network, you could see, LAN, you could see, for example, metropolitan area network. So basically, this figure is sufficient enough to explain what I said earlier. Okay. Now, from the topology perspective, what exactly is the topology? I would revise it again. So the topology of a network refers to the shape and arrangement of devices and communication. How these devices are connected to, for example. Okay. So it could be point to point. Point to point means two computers are connected directly with a cable, for example. So, or a single point of communication, for example, two people, they are communicating on phone, for example. It's a phone call is an example of point to point communication. So it means there could not be any other person or any other device, as a call receiver or call sender. Okay, so there will be a point to point communication between those two people, those two entities. Then we have mesh network. Okay, in mesh network, every device is connected to every other device. So every device, like imagine there are 10 computers, all of them, they are connected to each of them. So, and then actually this topology is used in as an internet backbone. Now, star, like I gave you another example earlier in very small aperture terminal VSAT communication, for example, a network, okay, which consists of multiple devices, for example. All of them, they are connected to a central device, which is a server. Okay, so it follows a client server architecture. All those devices, they have to communicate with the server, and server responds to all of them. Okay, so this is star topology. Bus topology, very simple. A network where every device is connected via a single cable. Okay, here, yeah, called a bus. Cable TV network, for example, is the example of classical example of topology. You will see the figure, then it will be extremely easy for you to understand. So let's say this one, for example, this is a better representation of these topologies. So you see here in the first figure, if I could, yeah, here. Oh, shit. So the first one actually represents, network topology type peer-to-peer. And in peer-to-peer, you could see here, you know, um, like this, yes. So point-to-point communication. You see here, two devices are connecting directly to each other. Then the bus technology uses a single cable, for example, and multiple devices are connected on that single cable. I gave you the example of cable TV, for example. Then you have ring topology, like forming a ring between the connected devices. Then you have a star topology. In the star topology, you see every device is connected to this, this central server. Okay, and this is tree topology. Okay, this is mesh topology, and also like one more important concept, these topologies could be combined together as well, and they called hybrid topologies. Okay, so now next slide is about architecture. I gave you an example of vSAT communication. So peer-to-peer, you understood all this concept of peer-to-peer communication, like two devices, two entities, they communicate directly. Client-server architecture means multiple devices, they are connected to a server. Okay, so the web is actually the example of this client-server architecture. Then you have a master-slave architecture as well. So this master-slave architecture means a network where one device acts as the master and controls the communication of other devices such as slaves. So Bluetooth network, for example, is an example of master-slave architecture. Now, based on the functionalities, if I could explain, based on the functionalities, they they could be classified as personal network. Like if I need to share the file from one of my device and it's connected to Wi-Fi or connected to YouTube, to Bluetooth, for example, with another device. If I'm sharing this information from one device to another device in a local controlled environment, it's like a personal area network for individual use. Okay. Now, enterprise network, a network that connects devices within an organization. So with the business perspective, okay? So personal network, business network, data center networks, industrial networks, social networks, there exist a lot of different kind of networks based on the functions, okay? Now, second topic we are starting. MAC address and IP addresses, okay? MAC actually are physically burnt addresses, okay? These are physical addresses and they are physically burnt on this network identity card, NIC. You see, network identification card or network, yeah, it is something like this. Okay, so this card, for example, NIC card, we used it to, and this card is actually uh, added to the computer, for example, and we add, every card has this physical MAC address. It's a 48-bit hexadecimal number. When I say 48-bit hexadecimal number, it means it could be like this 3C, for example, okay, colon 15, colon C2, CE 7C42. Now you see here, there are two parts of this. Now, how can you find the MAC address of your computer, for example, MAC address of the NIC that is installed on your computer? You could go into the terminal CMD and type ifconfig, simple, in Windows. So when I type this ipconfig space minus all in my terminal, I got this. Okay, so I got this MAC address. You see 50 minus 5A minus 65 minus 74. Actually, this is the interface of Wi-Fi, wireless, okay? So here you see, for example, IP address as well, 192.168.1.154. This is IPv4 and IPv6 as well. So I will tell you later, for example, the difference between these two. And here you see DHCP protocol is also enabled. We will share them. We will discuss them later. And DNS server as well. So you see all of these devices, they are connected together. Now, if you use this tool, for example, if you go on this website, aruljohn.com, for example, and you can search, for example, the MAC address, okay? So just to know what the vendor, for example, or manufacturer, okay? As I told you, the first part of your MAC address. So the first part of the MAC address, for example, is developed by Azure Wave Technology, and the address of the company is here, for example, and they have this range. Now, as I told you, like IPv4, for example, it's Internet Protocol version 4, Internet Protocol version 6. Okay, so these are unlike MAC addresses, these are logical addresses. When I say logical addresses, means they could be changed. Those MAC addresses could never be changed. Okay, so now IPv4 is deployed since 1981, so it's a bit old. Okay, and it can provide up to 32-bit IP address. I will explain you, for example, like you see here, we have 192.168.5.18. Okay, so this is a typical example of a IP address, and it contains numerical decimals. So here you see after 192 there is a dot. Okay, 168 there is a dot, after 5 is a dot, then 18. So this, for example, first part 192 is a octet. When I say octet, it means it contains, like if you convert it into binary, for example, it will be containing 8 either zeros or ones. We will see them later as well. And 168 also like contains in binary 8 different bits. Okay, then 5, then 18. So this is dot decimal notation. Okay, then we have DHCP or manual configuration. This IP addresses can be assigned either using dynamic host control protocol or using manual configuration. Okay, and it can provide up to 4.3 billion addresses. You see, like 4.3 billion is a good number. IPv6, 128-bit IP address, and it can provide like up to 7.9 into 10 to the power 28. So there is an opportunity. A lot of IP addresses could be assigned. Okay, and they support auto configuration as well. Now, from IPv4, so I told you it's a 32-bit address, and I gave you an example of 192.168. Like from this domain, from this pole, for example, 21.76. So each number, I call it octet or is a byte. Okay, hierarchical address scheme. It's a hierarchical address scheme, for example. So actually this IP address 192.168.2176, it's a decimal number. Its equivalent hexadecimal number is this C0A8154C, and its binary is this. Okay, equivalent is this. Now, this IP address consists of two parts. First part is network part, another part is host part. I will discuss these two concepts in detail. So, for example, there exist 5 different types of IP addresses. Maybe I have a slide next. Yeah, here. So you see here, I told you IPv4 has 5 classes defined over range. Class A, for example, it starts from 0.0.0.0/8. So this 8 means /8 means this is a subnet mask. Okay. So what is this subnet mask? It means it shows you that only first octet is reserved for networks, and the next three octets, they are reserved for hosts. Okay, so you can, for example, accommodate like 256 by 256 by 256. So if you multiply these 3 octets, you will get the number, and that number you can, up to that number of devices you can connect. So here, from 0 to 000 up to 126.255.255.255. This is the typical range of class A. For class B, it starts from 128.0.0.0/16. Now you see, slash 16 means the two octets are reserved for network and two octets, the last ones, they are reserved for clients. Okay. Now from 192 to 128, sorry, from 128 to 191. Okay, between this range, it's class B IP address. Okay. Now, from class C, you see 192.0.0, it starts from 192 and slash 24, which means first three octets are reserved for network and last octet is reserved for clients, for hosts, for example. So you here in class C, we can accommodate only like 254 users. Okay. So what does it mean? It means like last octet, we have only 8 bits to change to, right? So and if we turn them on in the octet, for example, this octet, host octet, if either we can have like 8 zeros or maximum 8 ones, right? Or in between. So up to the power 8 means we will have like 256. And those two, for example, the first zero will never be used. It will be used for the as a network, for example, and the last one is not never used. This 255, which is a broadcast. Okay, so among between them, we can use from let's say 192.0.0.1 to 0.254. We can use to accommodate hosts. That's why I said only 254 users could be accommodated. Now, next we have class D IP. And here in these IP addresses, for example, they range from 224.0 to 239.255. These two and this multicast address, this IP address is called multicast addresses, and they are reserved for the protocols which use multicast communication. Okay. And then we have a class E IP as well. It's reserved for experimental analysis, for for protocol building, for experiments. You would be wondering like, where is 127? So you cannot find here 127.0.0.0. Anyone knows about 127.0.0.0? It's a loopback IP. So in order to connect our own connectivity, we use that IP a lot. Now, there is another difference between these IP addresses as well. We differentiate them based on as public or private IPs. Okay, so some IPs are reserved for private networks. So from class A, you see here 10.0.0/8, okay, is reserved for private networks. A company can have as many devices as possible, for example. So this is reserved for 10 for private networks. 172 from class B is reserved for private networks, and 192 from class C. This is reserved for private networks. So you will not be able to see these these three types of IP addresses on internet. Okay, so these are all private for private networks. Since these IPs are private, what does it mean? They should not be routed on the network. Okay, and for the on the routing for example on the network, they should have public IPs. Those public IPs could be like 8.8.8, for example. I will show you in detail later. So, and also like gateways should be able to drop these datagrams. Okay. Now, these are the two differences. So, public IPs, they are used on public networks like WAN, for example. Private IPs are used on LANs, number one. Number two, they are recognized on the internet. Okay. So, you can ping them, you can SSH them, you can telnet them, you can directly connect to those IP addresses, public IPs, I mean, and not recognized over the internet. Okay, and public IPs are unique over the globe. Private IPs are unique within the local area network. This is the main point. So we can keep changing those IP addresses as well. Okay, and most important difference is public IPs paid, private IPs are free of cost. Now, these are private IPs that I showed with you. I showed you earlier. For example, here you see network number from 10, let's say. I'm giving you an example. I told you that first octet is reserved for network. So this is network mask. Okay. Now, what does it mean? Number of networks. How many number of networks it can accommodate? Up to 126. And number of hosts per Why 126? Because you could start from 0 to 126, okay? The first object. So it could accommodate as many networks as possible with this number of hosts per network. So you see, it can accommodate already a lot of devices. For class B, for example, up to 65,000 hosts you can accommodate per network, okay, and number of networks, because now you see here 255.255, which means you can use two octets for the network, okay. Then in class C, you can accommodate 254, okay, different hosts, for example, per network, and in total you could create up to 2 million, more than 2 million number of networks, okay. And this 127.0.0, I told you, this is a loopback IP. It's used for localhost. Now, subnetting. What is subnetting? Subnetting is the process of dividing a larger network into smaller networks called subnets, okay? Why do we need it? Okay, why? Subnetting involves changing the subnet mask. You see here, I showed you here. This is the default subnet mask. Network mask is like, you see 255.0. It means /8. If I could represent it another way, it could be /8, which means only first 8 bits or first byte belongs to the network. Okay, and I can write for class B /16. For class C, I can write /24. Okay, so here also, like, so we need to change that subnet mask of the network, which determines how many bits are used for the network and host portions of the IP addresses. In default, for example, you saw per network in class C, we could use up to 254 different hosts. Okay, so subnetting can be done for any IP address, be it A, B, C, for example. So one of your network, let's say take an example of class C. If this class C, one of the network, for example, 192.168.0.0, let's say /24. So one first network, 192.168.1.0, let's say, this is a network. It can accommodate up to 255 or 254 users. But suppose I have to accommodate only 4. What should I do? Should I use the should I waste all these remaining IP addresses, because this network is going to provide me 254 devices to connect, right? But what if my requirement is only 4? So here subnetting plays an important part. And subnetting helps us to reduce this network congestion. Larger networks, they tend to to be providing more congestion, for example. And smaller network help us to improve security and simplify management. They make our lives easier. So I'm giving you an example. So here you see, for example, we have a network of 192.168.1.0, and its default subnet mask I showed you earlier is like 255.255.255.0, which I can simply write as /16. /24, sorry. So if I write 192.168.1.0 /24, it's perfectly fine. Okay. Now to do the subnetting, what I'm so my what is my target? Okay. If I want to accommodate, let's say 50 users, for example, what should I do instead of using all the default subnet mask, for example? What should I do? I need to borrow down 2 bits, for example, from the network, from the host side to the network. Okay, so from the host side to the network, if I borrow these with 60, yeah, network portion, you see here the new subnet mask will be here. So you see, this one was the in binary. This is the subnet mask of this is equivalent to 255. This is default subnet mask. So 255.255.255.0. Now idea is to borrow down 2 bits from this 0. Okay, so this, for example, this one here, you see, it should have been all zeros here. But what I'm doing is I'm just bringing these 2 zeros and converting them to ones. Okay. So when they are converted to ones, what happens is like 255.255.255 dot becomes 192. Okay. How? So basically, I told you, like, for example, for this zero, the first zero is 1. 1 plus 2, it's 3. Here it's 4. 3 plus 4, 7. 7 plus 8. Okay, 7 plus 8 is 15, 15 plus 32, like this. If you combine them all, this is 2 to the power 0, 2 to the power 1, 2 to the power 2, like this, or 2 to the power 7. Okay, so if you combine them all, it will be 255. Now, if only two bits are on, for example, this is 128 bit 2 to the power 7, and this is 2 to the power 6. So 128 plus 64 is 192. Okay, so this will be the new subnet mask. And when you have this new subnet mask, subnet IDs will be like this. So 192.168.1.0, this is going to be your first subnet. Okay, and this zero, because it's not giving to any, it could not be given to any device, for example. The zero is your network, is your subnet ID. Okay, and the last one will be your broadcast, which is 63 here. So you can accommodate up to 62 users from 162 devices, for example, from 192.168.1.1 to 192.168.1.62. So you have now like four subnets. Here you see, for example, you have first this one, then you have second one, then you have third one, and here you have fourth one. So in total, what you have done is you have divided a class C IP into four smaller subnets. Okay, so this network is subnetted into four subnet, each with 62 hosts. Now, in order to communicate, if you are creating a lane of these IP addresses, for example, you will have four different networks, and you will have to use here a router to communicate between them. Okay, this is an important point. Now, fine. So here, then another important concept comes in, which is called network address translation. Okay, this is also a kind of a protocol or a technique. So this network address translation, NAT, is a technique that allows multiple devices on a private network. So you see here you have a private network and having 10.0.0.4 IP addresses. So they are all connected on class A IP. Okay, and so on a private network to share a single public address. Okay, the address is public, that is going to be shared on the internet or other network. NAT provides a layer of security for the private network because it never shows the private IP addresses. Okay, we will be using this NAT in our lab as well. So at this stage, you should understand that this protocol is only used for hiding the actual IP addresses with the public IP address. Okay, very simple. Now, third topic is TCP and UDP. TCP stands for Transmission Control Protocol. Okay, and it's a core protocol for Internet Protocol suite. It is actually the fourth layer of OSI reference model, and it sits on the top of the IP layer. IP layer is called network layer. Okay, and this protocol is meant to provide host-to-host communication services for applications. So here we have two protocols. Transmission Control Protocol, TCP, which I said earlier as well, it provides a reliable and ordered communication channel between applications. Reliable means, why I'm saying it's a reliable protocol, because it receives acknowledgements. Okay, every packet is received, the packet received is acknowledged. Okay, and ordered means there is a sequence number. Okay, every packet is contains a sequence number, and they identify both sender and receiver. They identify the packets or the order of the communication from those numbers. Okay, then we have UDP. It's a lightweight protocol with lower overhead, faster as well, but it doesn't provide any reliability. So basically, TCP is preferred for text-based communication, and UDP for video or voice communication. Now, the TCP IP, for example, here a packet looks like this. So it's reliable. I said it's reliable because every packet is acknowledged. Okay, so if a packet is missed during the communication, the receiver is going to notify the sender that this packet with this sequence number is missed, and they are in order. Okay, and they are bidirectional byte streams. So you see here, here in the source port, for example, you will find the port number. important concept, destination port number and sequence number, right? Like I said, and acknowledgement number as well. So every packet is acknowledged, okay? And this is the length, the flags, we will discuss them later. Now, connection setup, for example, how TCP protocol works, okay? So here, for example, there are two devices, let's say. When they are connected together, client, okay, this one of the devices called client, another device is called server. In order to establish a connectivity, this client sends a sync message to server, okay, and the server receives that sync message and sends back the acknowledgement of that sync packet, okay, and then client again sends a acknowledgement of receiving the sync packet, okay, receiving the sync, the acknowledgement of sync packet. So it's a three-way handshake protocol. This is why it's called three-way handshake protocol, okay. So now imagine for every packet, for example, if they repeat this procedure, it will be difficult, okay. So that's why TCP is comparatively slower communication but reliable. Now, as I showed you here in the flag, for example, flags, you will see these kind of information. Sync, which is synchronization, if the packet is of synchronization type or its acknowledgement type, once this communication is completed, they just build the connection, okay? And when they are terminated, they will use, for example, fin to finish that connection. So this is, I told you, for example, client sends a sync packet, for example, with the sequence X to the server. Server receives that packet and sends back the acknowledgement, okay, and with the sequence of X plus 1, for example, and then the client again sends the acknowledgement of that acknowledgement received by the server from the server. So here I show you here a three-way handshake process of captured on Wireshark. So here you see type of the packet sync. So sequence 0, okay, here this is window size 655535, length 0. This one, for example, you see, trust me, we will be discussing them all when we will have lab. So here you need to trust me. Sync acknowledgement sequence 0. So these are acknowledgement you see received from the server, and then this client sends the acknowledgement of this received sync plus acknowledgement. Okay, so this is why it's called handshake protocol. Now, ports and protocols. Before jumping here, I will show you here, for example, if you could see what is this protocol here, if you could see, like source port is 4992. See here, sorry, yeah, here, for example, you could see 49, this one. So this is source port, and destination port, the packet I already showed you earlier, and sequence number, okay, and here the packet flag that I showed you, okay, and this is window size. We will discuss them later as well, so don't worry. Now, ports and protocols. What are ports? Ports and protocols are the means by which devices on a network communicate with each other. Like, think of the port as a logical endpoint, that identifies a specific service or application running on a device. A protocol, as you might know, is a set of rules and standards, that define how the data will be formatted, how the data will be transmitted, and how the data will be received over a network. Okay, so these are the standards they are followed in the communication. HTTP, as an example, for example, I would like to show you the difference between ports and protocols, how they are connected, okay? So hypertext transfer protocol is HTTP, and basically it uses TCP port number 80 by default. But it could also use other ports such as 443. You might have heard about HTTPS, which is secure version of HTTP. Make sure that you always use HTTPS, not HTTP. We will see in detail also, like, what is the difference between these two protocols. And it uses 443, okay? And HTTP basically uh, is a web application protocol, and it transfers web pages and other resources over the network. It's an application layer protocol, I would say. Then you have FTP, file transfer protocol. It basically uses TCP port number 20 and 21, but by default. But it could also use, 22, which is reserved for secure file transfer protocol. Okay? And file transfer protocol means it's used for to transfer files between the devices over the network. Now, DNS, very important component that provides you internet. Okay, domain name system. So I will just to give you a definition of what this protocol does. For example, it just gives you the path, for example, where you can get the internet. Okay, so FTP uses UDP port 53. This is old. Sorry. This is not FTP. This is my mistake. Sorry. This is DNS. Okay. So this DNS uses UDP port number 53. Sorry for this mistake. By default, but can also use other TCP ports as well, like TCP port as well for larger queries. Okay, so DNS resolves domain names, like for example, because it's impossible for us to remember IP addresses of all the pages. For example, if I need to remember, if I need to access www.google.com, okay, if it was not a DNS, for example, I would have to remember, the IP address of Google, and imagine it's extremely difficult. So this translation is done by DNS actually. Okay, it provides IP addresses. Now, then you have DHCP, Dynamic Host Control Protocol. This protocol uses port number 67 and 68 by default. So what is the role of this dynamic host control protocol? Basically, this protocol assigns IP addresses on the network, the IP addresses I showed you. Okay. So how does it work? For example, you need to assign a pool of IPs to this DHCP, and it will take one by one every IP address, for example, and assign to another, to every incoming connected device. Okay. So there are two types of assigning IP addresses on your machine. Either you could do it manually. You need to enter your IP address by your own, for example, 192.168, whatever, or you use DHCP protocol, for example, to do this. Then we have, as another example, we have SSH. It uses secure shelling, actually, it stands for. It uses port number 22 by default, but it could use 2222 as well. Okay, and SSH is a secure. Why is it secure? Because it is used to establish secure and encrypted communication between devices over the net. Now, OSI reference model, the last topic of this video. You know, OSI reference model, it's also called 7-layer model, and there exist different protocols on each layer. So you see here the very first layer, which is called physical layer, second layer data link layer, third network, fourth transport. We were here when we were discussing TCP and UDP. We were on the net transport layer. When we were discussing IP addresses, we were here on the network layer. When we were discussing MAC addresses, we were on the data link layer. When we were on the physical media, for example, network media, we were using physical layer. Okay, and so these first, for example, top three layers like these, for example, they are called software layers. Okay, so application layer, for example, like uses application protocols like DNS, HTTPS, SMTP, FTP. These are all application layer protocols. And here on this presentation layer, for example, this data is represented as .jpg file, .mp3 file. So every packet is represented by a unique format. That format that need to be agreed upon by the sender and the receiver. Okay. Then you have like session. So this layer is actually used for creating a session, managing a session, and terminating a session. So the three different roles: creation of a session, management of a session, and deletion of a session. Then you have transport. I discussed TCP and UDP. They both work on this layer. On network, IP addressing. Okay, and data link layer, switches. Okay, and it's a combination of switches plus this MAC addresses, for example. Yeah, somehow it also has logical link control as well. We will see somehow. And physical link is like RS-232, for example, you use different connectors. These are cable type. RJ45 is the Ethernet connector that connects you to the computer, okay? Or 10 base T, these are Ethernet types, DSL at 02.11. So this is, actually, this was made to understand, and troubleshoot different networks. It's extremely important topic. Now, as I explained earlier, in application layer, this application layer provides you an interface between the user and the network, right? So on the network, if we are searching something using HTTP, we are searching something using SMTP, whatever we are using, we are doing web browsing, it means we are working on the application layer. In presentation layer, the data is compressed and translated. So, for example, once you have created your data, I'm making a video, let's say. Now this video needs to be saved either as .mp4, mp3, or .mkv, .flv. These are different extensions. So this is done by the presentation layer. On session layer, I told you that this layer is actually responsible for establishing, maintaining, and terminating the connection between the devices. Okay, so session management is done by session layer. Transport layer, as you see, for example, provides a TCP, UDP, secure TCP, for example. Okay, and it also does detection, error detection, correction, and flow control as well. Okay, so these things, error correction, detection, flow control, this could be, um, for these topics, I would recommend you to go for a network communication course, for example. On network layer, you see this layer routes and forwards the data packets across this network. So, and on network layer, it will be IP, all IPs, okay? IP addressing, fragmentation, congestion. We will be discussing all these protocols later. Data link layer protocol, for example, this second layer of the OSI reference model, okay? And this on, for example, data link layer means the hardware that you are using will be only switch or bridge, for example, okay? And this is in local environment, you are going to use the data link layer, okay? And then physical layer means all the physical connectivity, the medium, okay? The raw bits over the physical. So this layer transmits and receives the raw bits over the physical medium. It also defines voltage, frequency, modulation, different. Some protocols here, I showed you example as well, RS-232, USB, and Bluetooth. Okay. So, are you ready to create a simple network? Okay, we can try to create a simple network like we can use a packet tracer to create a simple network. Okay, a video on how to install this packet tracer, but at this moment I'm believing that you could be able to download this Cisco packet tracer, which is a free simulator. Okay, you can download it from Cisco's website, for example, and otherwise I will try to create another video on this. So try to, okay, leave me a comment if you are unable to install this. Okay, so now let's create a simple network. As I told you, we need to have, the end devices. And let's say in end device, I use laptop here. Okay, so this is the laptop. And here, for example, you need to configure the IP addresses. Here you see, you can use either DHCP protocol, or yeah, this one, for example. So you are required to use either DHCP, means let the protocol work, dynamic host control protocol, or you can statically or manually assign IP addresses to this machine. Okay, and yeah, so for example, we have this laptop first, and in the LAN, for example, what you are supposed to do, for example, in as an intermediary device, what should you have? You should have, you know, switches, for example. So here I take a simple 2960 switch, and I connect these two devices together. So you see here you have this straight cable, okay, and you use this fast Ethernet 0, and also on the switch, you use fast Ethernet 0/1. So these are different ports, on this switch available. Okay, so you have in total 24 ports of fast Ethernet and 2 ports for gigabit Ethernet. You connected them together, and now, for example, if you have another device, let's say end device as well, which is also a PC or a laptop here, and I connect, for example, these two devices as well, fast Ethernet 02 with fast Ethernet 0 of this machine. Okay, now let's see, for example, if we can connect to this machine. So here you need to configure IP addresses. For example, if I'm using, you know, fast Ethernet 0/0, I could use, DHCP protocol as I told you, or I'm using static IP address, which is 192.168. Mind you, this is a class C IP address and reserved and a private IP address. Okay, so I'm using 1.1. I cannot use 1.0 because 1.0 is a network IP address. When you click this one, the subnet mask automatically pops up and it's automatically filled. So this is default subnet mask of this. Now, since here there is no router, so I'm not adding any gateway here, okay, at the moment. So you could see, for example, physical here looks like this, and configuration wise it looks like this, for example. So you could use here the default gateway, but I don't have the gateway, for example, at the moment. Gateway means the router your LAN is connected to. So that's why I'm not adding anything here, okay, at the moment. Now, on the laptop, if you want to communicate with these devices, you have to be on the same network, okay? So, first Ethernet 0, you remember we entered here 192.168.1.1 we added on the PC. Here I'm doing 2, for example, okay? And here the subnet mask automatically comes in. So this is, for example, I'm referring to IP address. Okay, this is IP address of this machine, this laptop that you have connected, and this is automatically inserted subnet mask. Okay, now how do we connect? How do we check the connectivity? We click this, for example, and we go on the desktop, and on the desktop we select this command prompt. Okay, and command prompt. I click command prompt. I see is if we hit enter, we can see that we have IPv4 address assigned on this interface, which is 192.168.1.1, and the subnet mask is 255.255.0. Okay, now if I need to check the connectivity between laptop 0 and PC 0, what I would do is like I would try to ping. Ping is a small utility of ICMP protocol, Internet Control Messaging Protocol, which is used to check the connectivity. Okay, so 192.168.1.2. This 1.2 is the IP address of this machine, PC minus PT, PC0. Okay, so if I get the response of this packet, for example, it means that my device is connected. Okay, so we can see that we received the messages, we received the replies of our ping. It means that our devices are connected. So we have, seen a simple network of two machines connected together, and we pinged them as well, so to see if they are connected or not. Okay. Now, in the next lesson, what am I supposed to do is like I would try to create a ethical hacking lab. I will show you practically how we can create like a network of three devices at least. When I say at least means like as on my laptop if they are working. Okay, so the network will be comprising of Kali, okay, which will be a take machine, a taker machine, and there will be meta exploitable that is called victim, and we will try to find, for example, either Windows or Ubuntu device as well. Okay, so we will have three different virtual machines. I will show you, I will explain you how uh, we use VirtualBox, for example, to simulate this environment and how we can install all these machines. So stay tuned with me. Thank you so much for your comments, for your views, and for your liking the content. I'm I'm so great, so happy. Thank you so much, and see you in the next class. Bye for now. Hey, welcome back. Welcome to Cyber Guardian Academy. In this video, we will guide you through the process of setting up your own network lab using multiple virtual machines. We will be using Kali, Metasploitable, and Ubuntu initially, and we will check and add other machines as well. So whether you are a security enthusiast or a student or a professional looking to enhance your skills, come, let's create our own network lab. Okay, it will be a valuable experience for you. So having a network lab is actually crucial from cybersecurity perspective. Okay, because we need to train and test multiple things, multiple tools, multiple commands, for example. So creating a virtual network, for example, will provide us a safe and controlled environment, practice various techniques and develop our skills. Okay. So without wasting our time, let's get started. Thank you. Now, okay, so how will your network look like? Why virtual machines? Just a one-liner that virtual machines are easier to manage, number one, and we can have one PC, multiple machines scenario. Okay, so managing one machine will be a bit easier. And here, for example, we will have multiple operating systems. In fact, we will start with 3 operating systems. Then we can add multiple another virtual machines for another operating system. We will see them later. Okay, so in this video, for example, what uh, I'm the learning objective for this video will be to understand the difference between virtualization softwares like VirtualBox and VMware. Okay, VMware is a proprietary software, whereas VirtualBox is an open source program. Create multiple VM machines with different operating systems. When I say different operating systems, means we will have like Linux in the Kali, for example, Metasploitable in Kali, in Linux in Metasploitable as well, and then we will have Ubuntu as well. You can create Windows machine as well. So we will, after downloading and setting them all, we will determine their IP and MAC addresses. Okay. And we will determine also their gateway address, for example, or domain name service DNS address as well. We will be also using ifconfig or ipconfig commands, for example, to test internet addressing IP addresses. We will see them. Understand how to test network security, network connectivity using ICMP protocols ping utility. Okay. We'll check them. We will see it. Now, our setup will be comprising of, at the moment, 3 machines. Okay, one will be Kali, another which is actually a attacker machine. Another one is Metasploitable, deliberately made for as a target machine. Then we will be using, at the moment, we will be installing Ubuntu. We will try to download and connect Windows machine later. But we will start with Kali, Metasploitable, and Ubuntu. So the network will look like this. On this computer, for example, I will have Windows operating system. So the host is Windows, and the guest operating systems are Kali here, for example. Here, it will be Kali, Metasploitable, and Ubuntu. Okay, so let's move now. Why VMware? Why VirtualBox? Why we are preferring VirtualBox? Because VirtualBox is open source. For me, this is the main motivation. Okay. Then, for example, for me, I'm not saying on behalf of others, but for me, for example, VMware has a complicated interface as compared to VirtualBox. And VMware also supports only VMDK format files, whereas VB supports multiple formats. So we will be downloading VirtualBox. Now let's download VirtualBox from here. Where will you download the VirtualBox? I can take you there, for example. Okay, here. Now you see here, where you have a VirtualBox here, you will go on this link, virtualbox.org/wiki, and downloads. I will leave these websites in the description as well for you. So here you can see, for example, for which operating system you want to download VirtualBox. Okay, so since I have Windows, I will click this Windows host, and you see here a download. has already been started. Okay, so I'm stopping it. Time to download Kali. So for Kali, you will go on this website, for example, and download this pre-built image for your VirtualBox. Okay, so we will click this VirtualBox, and you see here the download has already started. Since I already have downloaded them, I will stop this. Then we go on this website to download Metasploitable. Okay, since I already have Metasploitable downloaded, you just need to click this button. For example, it will be downloaded on your computer. Finally, we will download Ubuntu from osboxes.org. Okay, and here you see you have VirtualBox, VMware, and Info. So you can download the operating system for this virtual machine. It will be actually in .vdi format, VirtualBox format. So we will click this. If you click this, for example, it will again it will be started soon downloading. Okay, new virtual machines. So what you will do, you will click this new button here after installing VirtualBox, for example. You can name it, for example, let's say I'm naming it as Kali in capital letters. And here also it's a Linux based system. So I will select type Linux, and version, for example, you can choose Debian or whatever you want, for example, but I will go with Debian 64. When I press select, because I don't have ISO image, I will go in next. Here I will choose hardware. Okay, so I think for Kali 2 GB RAM is a bit low. We should increase, like make it 3 or 4, for example. It will work well. Okay, and then here, so for CPUs, for example, I would increase the number of CPUs. So I'm setting up 3. You can choose whatever you want. Then we have, we need to spare some hard disk for it as well. So 20 GB, I think, should be sufficient. Here you need to select this button, and where it says use an existing virtual hard disk file. Okay, so you will click this, and for example, here I have already attached those VDI files and VMDK files you see here. So you just need to unzip those folders and select metasploitable.vmdk, ubuntu.vdi, or kali linux.vdi, and you are done. So here, for example, if I select this Kali Linux VDI, okay, so by next doing just finish, it will automatically set up this Kali machine for me. Okay, so now if when I start it, for example, it will start. Okay, and we can see. So now what I'm supposed to do, for example, I'm turning off all these, turning on all these machines. Let's say here I'm stopping it at the moment, let's say, and here I'm opening it up. It's Kali. So another machine is Metasploitable, and third machine is Ubuntu. Okay, so we are starting them all. Let's see here the Kali. I can find Kali. You see here Kali. Here you have Ubuntu running, and you have Metasploitable as well. IPs of these machines. Let's see on Kali, for example, I am typing ifconfig, and it prints me 10.0.2.15 as IP, and the subnet mask is 255.0.0, no, 255.255.255.0. Sorry. For metasploitable ifconfig, I see 10.0.2. For example, I can show you here. So this one, for example, okay. So 10.0.2.54 is the IP address of this machine, and they both are connected together via, let's say, if you type here route space -n. So the gateway of Kali and Metasploitable and Ubuntu should be the same. So if I do IP address on Ubuntu, IP address, it will show me on inet address of this interface. inf0s3, I have this subnet connected. Okay, so now, for example, which is the IP address of Kali, it means we are connected. 10.0.2.15, you can see I am connected from Ubuntu with Kali, okay, and so Kali is connected with Ubuntu as well. For the meta exploitable, let's say if I could ping 10.0.0.15, let's 2.15, and this is Kali, IP address of Kali. So I can ping Kali from both Ubuntu and meta exploitable. And same, I can ping 10.0.2.10. This 10 is the IP address of this Ubuntu machine, so it should be pingable as well. So now that you have seen, I can ping all these machines together, which actually means the setup is now complete, and I can do the testing. Okay, so till now, for example, our task was just to complete the installation and check the connectivity. We have checked connectivity, and it's everything is seems fine, to be honest. Okay, so now let's get back to the video. Okay, so here you see, if I could show this, for example, we were here. Okay, I showed you VirtualBox, and we downloaded VirtualBox, we downloaded Kali. Okay, here, for example, the interface of Kali looks like this. We installed it, and then we installed Metasploitable. The interface you can see down there as a screenshot, and also like we have installed Ubuntu as well. Okay, so now the next lesson will be about introduction to security. We will be covering all the basic concepts of security. So thank you for watching, and see you in the next class. Bye. Okay, welcome back to session 2 of module 1, basics of cybersecurity. I'm Atabla, and today we will dive into cybersecurity. We will explore various threats, actors that can compromise our digital assets. Okay, so without wasting our time, let's see the outline of this talk. Okay, so first we will start by defining what we mean by secure, and then we will be delving into the basics of cybersecurity. Okay, and next, for example, we will be talking about threats and threat actors that could actually try to hack our systems, our networks, and we will talk about uh, some measures that could be taken to avoid these attacks. And we will conclude with the summary and the way forward for this presentation. Okay, so how do we protect our valuable assets? Okay, what does secure mean? Let's start from this point. What does secure mean? Secure, in the context of security, it means you need to protect your resources against unauthorized access, alteration, theft, or physical damage. So here in these figures, you see your resources, for example, they are secured by lock, for example, by some signatures, let's say keys, for example, sometimes from your smartphone as well. And this seal, for example, shows that this information that is inside this page, for example, is secure. And sometimes we try to open our locks using our smartphones as well. Okay. So but here, mind you, we will be talking about information. For us in cybersecurity, the valuable asset is information. Okay, so the main target will be to protect information against malicious or accidental access. Mind you, this hack or this attack, for example, sometimes happens due to the malicious activities of the hacker. Sometimes due to some accidental access, it could be also possible. So there exist multiple applications of securing assets. When I say asset means information, okay? So in online banking, this information is extremely crucial. We need to secure it, okay? From economy perspective, mobile phones, DVDs, players, okay, uh, all these resources, they require information to be protected. And in military also, like imagine if information that need to be shared among a particular agency, if it's this information is shared accidentally or intentionally to a enemy organization, let's say, what will happen? So this information becomes extremely important, and to protect this information is even more important, is of paramount importance. Okay, so how well the information is protected? Not too well, actually. So the point is, we sometimes it is because in cybersecurity, humans are considered to be the weakest link. So because of these human errors, for example, most of the time, we live in the false sense of security. Okay, we have already secured our system, but actually it was not, to be honest. So imagine here, for example, you can see two figures. One figure shows that a broken, for example, lock was found on the door. It was not well locked. Another table shows you the passwords that people use, for example, to secure their laptops or secure their mobile phones, for example. So you see, for example, simple passwords, they make the life of a attacker easier. So, in order to protect our resources, we must use extremely complex passwords, and we always take care of applying the security correctly. Sorry. So, what is cybersecurity? Cybersecurity is actually the way of protecting these information systems. Okay, practice of protecting information systems, networks, and data from unauthorized access. What is this unauthorized access? It means if someone else who is not supposed to access this network or resource is able to access it, okay? Use it, for example, or damage it. Okay, so basically, cybersecurity is the practice of protecting all these things, okay? Ensuring that all these steps they don't happen. Now, cybersecurity provides three basic principles. It works on three basic principles: confidentiality, integrity, and availability. We will talk about these concepts in the next slide as well. So, cybersecurity is extremely essential by providing these three, measures: confidentiality, integrity, and availability of digital assets. It it ensures us to safeguard privacy, safety, and trust of individuals. Okay. Cybersecurity also faces some challenges and risks as well. The point is, we are living in an age where where the networks are increased, exponentially, and the connectivity of cyber systems and infrastructures are growing rapidly. Okay, so number one, number two, for example, the gap of a cyber skills and resources, it is increasing. That's why cybersecurity, field will be a hot topic these days. Okay, so cybersecurity requires basically the expertise in multiple domains, like I told you before, in machine learning, in cybersecurity, in Linux, for example, in penetration testing. So the point is, we this cybersecurity is just not a easier technique. It requires a holistic and proactive approach. It should involve multiple stakeholders, disciplines, domains as well. Now, since cybersecurity provides confidentiality, integrity, and availability, I need to define them. What is confidentiality? Confidentiality assures that the information that you are getting is actually coming from the original person that you are supposed to get the information from, for example. So confidentiality means authenticate person that actually sent you that message, okay? So, and privacy, for example, it assures that individuals or controls, if it is my data, for example, I should have full control on my data or full influence on my data. Okay. Integrity means, if we talk about data integrity, it means that the information and programs are changed only in the specified and authorized manner. What does it mean? It means that from the sender and the receiver, the data that was sent, okay, the data that was communicated should remain unaltered, okay. It should be the same data that was sent originally and received, okay. And system integrity means that the system, the platform that you are using, for example, is not used unauthorized, okay. Only authorized person were supposed to use that system. And availability means the system, the network, the machine, okay, that is at your service, for example, should never deny the service to its authorized users. Okay, it should always remain available to its authorized users. Okay, so this is called availability. This CIA, confidentiality, integrity, and availability, is also called a CIA triad. Okay, and it's extremely important to understand from this, understand cybersecurity from this perspective. Now, NIST, this is the CIA triad I was talking about. So actually, it was NIST who actually defined this triad. Okay, so NIST is a national institute of standards and technology. Let's say, if I'm not wrong. So in its FIPS 199 standard, okay, this standard is actually for security categorization of federal information systems. Lists confidentiality, integrity, and availability as three main security objectives. Okay. Apart from these three, confidentiality, integrity, and availability, there exist two other parameters as well. What one is called authenticity. Okay. And what does it means? It means that whatever, okay, I do, for example, on the network or on the system, for example, it could be verified and trusted. Okay. This is also added to the CIA triad. And accountability as well. Accountability means I should be held responsible for what I have done on the network or what I was doing on the computer. It should not I should not be able to deny the fact that I did something. Okay, so accountability has also been added to this important concepts. Now, to be honest, cybersecurity is not as easy as it looks like. Okay. So it is extremely difficult. Why? Because it requires multiple skills across multiple domains. Okay. So one of the challenges, like while developing the mechanisms, potential attacks, often unexpected, must be considered. Okay. So when we are developing some solutions, for example, some systems, we could take care we should take care about unexpected attacks, but how we are not sure, like how we can which attack we could expect. Okay, so the procedure used to provide particular services are often counterintuitive. Okay, and the security mechanism typically involve more than a particular algorithm or protocol. Okay, and also they require participants to have secret information, which could lead to the issue of creation. Who is going to create that information, distribute that information, and protect that secret information? So this way, cybersecurity is facing a lot of challenges. So what what are the threats that cybersecurity is supposed to tackle? But before that, we need to understand what exactly is a cyber threat. Okay, so a cyber threat can exploit any weakness in a system, in a network, in a device, or data. Okay, so any exploit, if there is a exploit or a vulnerability in any computer network, for example, or a device, it could be exploited to mount an attack, to launch an attack. Okay, so this attack is, for example, called cyber threat. Okay, so this threat always remains there. If the weaknesses or the vulnerabilities, they are not removed. So here you see we have list of multiple cyber threats. In black, you see information gathering, sniffing, DOS, DDoS, password-based attacks, session hijacking, firewalls, and IDS. All these attacks, cyber attacks, for example, they are based on network. So they could be launched from networks. That's why they are called network attacks. These attacks, password cracking, malware attacks, footprinting, backdoor, privilege escalation, code escalation, these are called host attacks. Okay, and injection attacks, for example. And these attacks like injection attacks, SQL injection, phishing, buffer overflow, these are actually termed as application attacks. Okay, now common and more emerging threats these days. Have you heard of ransomware? Ransomware actually is a type of a malware that encrypts victims' data and demands a payment for the decryption key. So what do they do? How do they work? For example, ransomware attackers, they send a malware, for example, and this malware is able to encrypt all the data in the network or in the computer, for example, and ask for a payment, provide you the decryption key. Okay. So just to mention here, in July 2023, like 6 months ago, ransomware attackers extorted $176 million. Okay, more than the same period in 2022. Here is the link if you want to access this. Okay, so ransomware is the most severe attack, I would say. Then we have zero-day exploits, a type of attack that exploits unknown or unpatched vulnerabilities in a system or a software. It means that such an attack never existed actually. So, and maybe from the developer point of view, that exploit was never seen before. Okay. So, zero-day exploits have been used in some of the most notorious cyber attacks. In Stuxnet, this is net happened in one of the nuclear plant in Iran, and SolarWinds. Okay, SolarWinds is a company. So here I have given you the references as well. You could see. And then on the third number comes DDoS. DDoS is a distributed denial of service attack. Okay, this is a type of attack that floods a system or a network with traffic or requests, multiple requests from multiple nodes. For example, maybe zombies, they are sent to a particular server with the aim to slow it down or make it unavailable. Okay, this we call a DDoS attack. Then phishing, most common. Phishing is the most common attack these days. Okay, and actually it's a kind of a social engineering attack that users use, for example, to do fraudulent emails, websites, or trick users into revealing their sensitive information or downloading malware. Okay, even don't mind, even Facebook and Google were tricked out of $100 million as well. So imagine, for example, how smart these guys are. Then we have IoT based attacks. This is also an emerging attack, I would say, that leverages the Internet of Things devices since we are living in the age of IoT. So we have appliances everywhere, especially in the smart home environment where we have cameras and sensors. So these attackers, they could exploit those cameras even by exploit some weaknesses in the network hub, for example, or network router or modem, for example. And they could enter into your bedroom from your camera. So, and sensors as well to launch cyber attacks. IoT-based attacks increased by 100% in 2021 and caused privacy breaches, data theft, and physical harms. You go on this link and read more. Okay. So, current situation in 2023, for example, 48% of the organizations, they reported an increase in cyber attacks. So these are actually on the rise. These attacks are on the rise. But the point is 62% believe that majority of the organizations underreport cyber attacks. So people, they actually underreport cyber attacks. And if you could see this figure, I have taken it from internet and the source is mentioned here. You see 190,000 worth of attacks, for example, okay, are occurring per second. So imagine how difficult is the age is now, how difficult, how important actually is to prevent your system, network, resources from attackers. So, who are these attackers? I have said a lot of times attackers, attackers, attackers. Who are these attackers? We call them threat actors. And these threat actors, for example, they could be black hat. You might have heard about this black hat, white hat, for example, script kiddie or state sponsored hacker, hacktivist, for example. These are all categories of attackers. Okay. So these attackers, for example, if you want me to define them, these black hat hackers, for example, of course, their aim is to perform malicious activities, also without letting the organization know. Okay, gray hat hackers perform good or bad activities, but do not have the permission of the organization they are hacking against. Okay, so sometimes they do that thing for good purpose as well, but without getting the permission from the organization they are targeting. And hat hackers actually, they are called ethical hackers. They use their skills to improve security by exposing vulnerabilities before malicious hackers. So here, white hat hackers or ethical hackers, they talk to a company or organization, take the permission, for example, and then try to hack their network, their systems, their resources, just to find out the vulnerabilities. Okay, so we are here, white hat hackers. Skills means like imagine unskilled person or just a student trying different scripts or program to do something he likes or she likes, for example. State sponsored hacker, this is extremely dangerous. So because he will have all the resources available from the government. So this kind of hacker, for example, is extremely dangerous. So they are hired by government or entity related. These are called state-sponsored hackers. Then comes hacktivist. So hacktivist means one who hacks a system for a cause, let's say political agenda. Okay, so these are called hacktivists. Now, these threat actors can have different motives, capabilities, and resources, like I mentioned. State-sponsored hackers, for example, they will have more capabilities. They will have more resources available. Okay, and they have more sophisticated and customized support, more sophisticated malwares and exploit available at their services. Okay, so idea is to tell you that these threat actors, for example, have multiple motivations. Cyber criminals, mainly they are motivated by money, so most of the time money. For hacktivists, for example, they are motivated by social or political issue. In terms of capabilities, they have different capabilities. State-sponsored hackers, for example, they are expert in their field, let's say. And in resources, for example, also like imagine a study or, for example, a student of cybersecurity, would not have enough resources as compared to the resources of a state-sponsored hacker, for example. So sometimes changing profiles also work. Sometimes non-state actors become, state actors, for example. So changing profiles and state actors, this is also a relatively new topic that deals with the evaluation and impact of non-state actors in the global arena, especially in relation to conflict and security issues. Okay. So the growing role of non-state actors is changing the political, security, economic, and social environment. I refer to this link, for example, if you are interested to read more. Stakeholders wanted why and how European Union organizations, agencies involve non-state actors. Okay, so now we have talked about what does security mean. Then we have talked about cyber security. Then we have different cyber attacks. Then who could attack us? Attackers. Now it's the time to understand attack vector. Okay, what is an attack vector? So this attack vector is actually a path, hacker could take, for example, to gain access to a host or a network. Okay, so in order to deliver a payload or a malicious outcome, for example. So advanced persistent attacks, APTs, okay, these attacks, these are advanced level state sponsored attacks, and these attacks typically use zero-day attacks. Okay, most of the times they use zero-day attacks. Then we have cloud computing and cloud-based techniques. They also look for the flaw in client applications, for example, and access the client data. Another attack vector is viruses, worms, malwares, ransomware. So imagine, for example, if you receive a link, phishing link, for example, and there is a malware or ransomware, okay, appended to that link, for example. So it's very common. It's very common. Or imagine you are downloading a file, and that file, who will check if that file is a benign file or is a malware, for example. So these this is also a emerging tech vector. Viruses and worms are the most prevalent networking threats that are capable of infecting a network within seconds, very quick. Then we have web application threats like SQL injection, cross-site scripting. Okay, so these are attack vectors. There could be many more. Okay, attack vectors that attacker could exploit, for example, to reach out to your network, to your resources. Now, how to avoid these attacks? This is extremely important. Okay, mitigation is extremely important, but without going in detail, I would list down here top 5 best practices that you could do, for example, to have your network secured. First, implement strong password policies. Now, imagine, for example, your router or the modem that is connected with the internet service provider. Have you ever checked what is the username or a password on that modem is? In most of the cases, it's admin. I don't know. So the point is, if the pass username and the password on your modem that connects you to ISP, for example, has admin as username and password, how will you be able to protect your home, for example, from attackers? So implement strong password policies. I'm saying not just to the end users, but also to the network users, network administrators, people those are working in this domain, and regularly update and change passwords to enhance security. So this is also a common practice that we use these passwords for example, across different applications. So imagine I have a complex password, for example, but I use it across multiple websites, across multiple devices. This is not a good practice as well. So first, here the take home point is your password should be very strong. Number one. Number two, you should have different passwords for different resources. Okay. Now, second point is like best practices is page management. Okay, you might have heard about this page management. So sometimes what happens is like organizations, they have, let's say, created a operating system or a program, but there was a zero-day vulnerability in it. So they take some time, for example, to patch that vulnerability. Okay, so and they will force us, for example, to update our operating system or that particular program. This process is called patch management. Now, I must say that this is also extremely important. Okay, keep your program, keep your operating system, or keep whatever needs to be updated. Okay, and regularly update. Don't wait for like last day, for example. As soon as the update is available, make sure that you will update your. Then we should have a secure network infrastructure. Okay, so a network without firewalls, for example, will not be able to save your resources. So use firewalls, intrusion prevention and detection systems, okay, and secure Wi-Fi protocols to protect network integrity. Okay, intrusion detection systems should also be installed. So a common example of intrusion detection, for example, how your system will detect whether intrusion is being done or not. Is there an intrusion at the moment or not from the network analysis, let's say. Okay, so there should be this system, and this system should, for example, this system should be able to detect whether or not this query that is coming in, for example, is an intrusion query or it's a benign query. Okay, then we have another point that you should segment networks. When I say segment networks, it means the size of the network should be smaller. Okay, so for example, imagine you have a building of 5 floors, let's say. Rather than creating a single network for for the entire building, I would divide this entire network into 5 different sub networks. So in segment those networks. This makes attacks a bit difficult. And implement least privilege principles. So give the, for example, give the internee, let's say, okay, not the privileges of a CEO. Okay, if there is an internee, for example, he should have the access rights of an internee, not of a CEO. So implement least privilege principles and regularly review and update user access permissions. Finally, the most important thing, this is the most important thing that I would say: educate and train employees. Conduct regular cybersecurity awareness training to employees. You see, that's why they say humans are the weakest link in cybersecurity. So, in order to counter this fact, you should, educate and train employees very, very well. I'm talking about organizations, and teach them to recognize phishing attempts and other social engineering attempts, at least. Okay. So, in summary, we said we discussed threats and threat actors in cybersecurity, and the differences and similarities among the attackers in terms of goals, capabilities, tactics, techniques, and procedures. We talked about attack vectors as well. We talked about different attacks from network, from host, from application perspective. So, what are the key takeaways from this presentation? The key takeaways are, first of all, cybersecurity is about proactive defense, not just reactive measures. Okay, don't wait for the defense. Okay, be proactive in your defense. This is one thing. Second thing is, cybersecurity is not a responsibility of an individual. Okay, I must say. So this is a shared responsibility of users working in the organization itself, and the community. Continuous improvement as well. Okay, adopt a mindset of continuous improvement in cybersecurity practices by educating and training your employees, by educating and training the ordinary person. They should be able to differentiate. They should be able to respond to these social engineering attacks like phishing. Okay, so thank you so much. In the next video, for example, which will be module 1, session 3, it will be all about introduction to Linux from ethical hacking perspective. So till now, thank you so much for your comments, for your likes, for your engagement. Extremely happy, appreciated. Thank you so much. See you next time. Hello and welcome to Cyber Guardian Academy. My name is Dr. Ataullah. And today I'm talking about network analysis. We will start with communication analysis, and it's a hands-on lab. So I will demonstrate you how to collect different packets, for example, and then how to analyze them and interpret them. So without wasting our time, let's jump in. So this is the outline of my presentation today. We will start with the introduction of analysis. Why is it important, and how should we do it? Then I will show you, we have already created this. If you have not yet created this virtual machine setup, I would recommend you to check the video, okay, where I discuss, I create this network, okay. And then we have introduction to Wireshark. We will discuss how Wireshark is unique. How is it better, for example, and why should we rely on it? Installation of Wireshark on Kali, I will demonstrate you how to install Wireshark on Kali, and I will then demonstrate how the network traffic could be captured. Okay, so let's jump in. On this side, you are watching, for example, interface of Kali. Kali is here, and here you have Ubuntu running. Okay, so network analysis. Why is it even important? Okay, so network analysis or communication analysis, I would say, is a quantitative and qualitative method. Method of what? How information, messages, and decisions flow through a network. Okay, network nodes and links, for example. So, network, mind you, we have already covered these basics just to be sure that we are on the same page. A network is a physical system, okay, such as a computer network, for example. So, we have created a computer network of two virtual machines with one host machine, right? So, we have a network of three machines at the moment. So, this is how the computer networks are created, okay? This way, multiple organizations they create larger networks or segmented networks or multiple networks based on their needs. In figures you see here, this is the icon of Wireshark, Nmap, and Packet Tracer. So Packet Tracer is a Cisco proprietary tool that simulates, the networks. You could use this tool to create networks, to understand how the network is working, for example, how different nodes are communicating. You can learn from this Packet Tracer. I have in mind a video to create on this Packet Tracer as well. Nmap we have, okay, so this is for scanning. We will be using it in our next presentations. And Wireshark, we are going to install it today and learn how we can use this, okay? So without, let's jump directly. Now, what is exactly network analysis? Okay, I told you this network analysis actually makes us understand how the data flows through the network. Okay, and based on this understanding how data flows through the network, we can actually see how this flow actually affects the efficiency from congestion point of view, reliability, how many packets were lost in the middle, for example, security, okay, and quality of the network services. I will talk about the security now. So security is actually extremely important these days, and detecting and preventing cyber attacks is extremely important. So this way, for example, by just analyzing the traffic on the network, for example, we can identify, okay, whether this traffic is anomalous, is a benign one, or it's perfectly fine, it's a normal one. Okay, so we can, based on this analysis, we can actually identify the net from the network behavior if this is an attack or not. Okay, and this is also important, for example, from troubleshooting perspective. Okay, so from troubleshooting perspective means we will be able to diagnose and resolve packet network problems such as congestion, for example, latency, how long this packet is taking to reach the network, for example, or the end node, packet loss, how many packets were lost in the middle, and misconfiguration, you know. So by monitoring and analyzing the network performance and health, for example, okay. So this way, this network analysis is also extremely important to troubleshoot your existing network. Then for the optimization as well. So it's important to, to optimize the network to work best for your scenario, for example. So how we can, we can use this network analysis to improve and enhance the network performance. Okay, like, and the capacity as well, and the functionality as well. So by designing and testing different architectures, protocols, and policies. So these are three main. There are many. There is a long list of applications that we could use for in network analysis, but these are the three most important ones. Now, okay, so now that you know, for example, why network analysis is important, let's see our virtual machine setup. Okay, so this is how our network looks like. We have a Kali here, for example. We created this lab earlier. If you we create this network setup earlier. I would suggest you to see Lab 0, for example, of this series. So now here you have a Kali Linux installed, which is actually a target machine. I just wanted to repeat this point. This is a target machine. These two virtual machines, this is Ubuntu Okay, and this one is meta-exploitable. These two are victim machines. Okay, so simple network comprising of three virtual machines hosted on my Windows machine. So in fact, there is a network of four computers, but I'm not using my my host machine in this network. Okay, so now we have here, you see, for example, we have Ali here. If I could show you what the very first thing that I do is ifconfig. I check, for example, the IP addresses. As you see, on Ethernet 0, I have 10.0.2.15, which I could use for internet, for example. And then on Ethernet 1, I have this 192.168.54.5. Okay, so and on Ubuntu machine, for example, because in this lab we are not using Metasploitable at the moment, because it's sufficient to have a network of two virtual machines and to understand these packets. So here, that's why I have here this virtual machine, and it has this IP address of 192.168.54.3, okay, slash 24. So you see here these two machines, Kali and Ubuntu, they are on the same network. Okay. So, but still, just to be sure if they are still on the same network, what I do, for example, I ping, I'm on Kali now, ping, yeah. So it's pinging, Control Z, let's say, and I ping 192.168.54.3. Let's see if it is pinged. Yeah, a bit slow, but it's still, let's make it a bit bigger. Okay, so now we can ping this machine Ubuntu, which is perfectly fine, and which means we are connected. Okay, so this is one ping that I sent to this Ubuntu machine. But what if I ping www or -c? Let's say we are sending 10 pings to www.google.com, let's say. Okay, so yes, so from ETH 0, Ethernet 0, I'm able to ping google.com, and from Ethernet 1, I'm able to ping my virtual machine Ubuntu. Okay, so we are well connected now. Now, what is Wireshark? Okay, so Wireshark actually is an open source tool that lets you capture and analyze packet traffic, network traffic. Okay, so Wireshark is an open source. What does this mean? It means it's a free software. You can download it. Okay, you can play with it. You can distribute it. Do whatever you want to do. For example, it's open source. Okay, it's completely free. Now, okay, if we discuss features of Wireshark, the very first thing that comes into mind is it's open source. Okay, Wireshark is completely free of cost. Number one. Number two, it can capture live traffic. Okay, so capture network packets from various sources. You have to mention explicitly on from which interface you are actually you want to monitor that traffic. Okay, so it can use Ethernet. I will show you in the next slide as well. It will show you the Ethernet, ETH0, ETH1, like in this case we saw, and Wi-Fi, Bluetooth, USB, whatever source you would like to define. Okay, then it can display filters. Okay, so you can analyze those captured packets based on different filters, such as protocols. For example, in display filter, if I write DNS, it will show me only the packets of DNS protocol, or based on the IP addresses, based on the port numbers, for example. So we can use these filters later on, and we will see them. Then it supports protocol analysis as well. So inspect the details of each packet. I will show you how, for example, the headers of each of the packets be seen. And we can then, after analysis, we can save and those packets, we can export them, we can import them, we can play with those packets. Okay, and this data could be saved as pcap file, which is actually original file, original format of this Wireshark. You could save it as CSV, as XML, whatever way you want. Okay, so Wireshark actually, to be honest, is widely used by network professionals, even researchers. They are widely using these tools, this tool. Okay, Wireshark. So, and it is because I told you it's completely free. Additionally, the most important benefits that it provides is like it can modify, you can use it, you can distribute it, Wireshark without any cost or restriction. So this is a very nice addition. And it supports over 3,000 network protocols, which is really great, So, you know, with free of cost and with this much support, I would love to use this Wireshark. And it has an extremely useful user interface. So we can navigate through different panels, for example, and see how things are working. Mind you, it has a large community as well. So you can find many tutorials, many, conferences, many certificates, podcasts, live, for example, to understand if you want to learn Wireshark. Now, let's install Wireshark on Kali. Now, the very first thing is like, if you ask me to tell you the process of installing Kali, it is composed of only three main things, okay? Three main commands. Now, in Kali, for example, the very first thing that must be done in order to install effectively any protocol or any package, for example, what you do, we do sudo apt update. So this is the very first thing that we do, okay? Sudo apt update, it will upgrade if something is missing from my system, okay? So this is the very first thing that you will do. The second thing is you are required to install it. Sudo apt, so this is simply the command up to install Wireshark. Okay, so here with this command, you should be able to download this Wireshark from the main repository and install it on your computer. Okay, so here if you click this, it will, since it's already installed on my computer, 4.2.2 is its version. It didn't ask, but for you, it will ask you confirm and you have to hit Y, so here for example you have to hit this Y in order to confirm, okay, that you want to install this. So once you have uh, uh, typed Y and hit enter, it will be automatically installed and you will see, you will be able to get the terminal back, okay. So now here for example you could check the very first thing that you could use is like Wireshark minus minus version. You could check the version because I told you already I have this Wireshark 4.2.2 installed. You could also check and tell me in comments which version of Kali is installed on the machine. Okay, so now everything is set. We have Ubuntu install, we have Ubuntu, we have Kali on the network, and let's capture the packets now. Okay, so here I have written the steps. Now first example, you need to start Wireshark. So I have another terminal opened here which I'm using for opening Wireshark. So here you see simply typing Wireshark on Kali is sufficient. Okay, so when you hit enter, okay, Wireshark, no typing error, Wireshark should be working. So now here, the very first thing that I would like to show you here is like we can see a list of devices to capture packets from the main window. Okay, so here you see ETH1, ANI, ETH0, loopback, Bluetooth monitor, NF log. So these are different interfaces that you could use to collect to capture packet on, for example. Okay, so click the blue shark. So this one is exactly when you hit it, for example, when you click it, it will start capturing packets. Okay, and you should be able to see in the display filter all the traffic that is going through. Okay, so click the red button if you want to install this. If you want to stop it and save this packets, for example, so this data, you could click this and it will ask you where to save that data. Okay. So without wasting time, and then you can save that data as well. So let's go. Now here on ETH1, if you hover over it, this interface, you see you have an IP address of 192.168.54.5. So this network, mind you, actually is used to connect you to the Ubuntu. Okay. Then you have ETH0, which actually connects me to the internet. Okay. So network is connected on this and 10.0.2.15. Okay, is the IP address. This loopback is your internal IP. So what I'm going to do is, for example, let's say I'm using any, for example. Okay. Any, and I'm hitting this blue button. So you will instantly start seeing different packets captured. Okay. So, for example, if we ping from this machine now, for example, if I open this osboxes.org, just to give you an example, if I ping 192.168.5. No, 54.5 actually is the IP address of Kali. Okay, so if I do this ping, what will happen? So you see here, some activity has been started here. Okay, so you see here on Kali, we are capturing ICMP related protocol related data. So what is this ICMP? ICMP is Internet Control Message Protocol. Okay, so these utilities, ping, tracer out, for example, they belong to this protocol. Okay, now what we are seeing here is like this. If I break this interface in front of you, let's say we have here command panels simply. Okay, if I have, yeah, so you see this is what you already did. You selected some interface and you can see a list of packets being captured. Okay, so these packets are being captured now. And here, just to show you, for example, here, this one, for example, they are commands, command menus. This is your display filter. It's already written apply a display filter. So if you want to write ICMP, it will capture ICMP packets. DNS, it will capture DNS packets. ARP, address resolution protocol, it will, it will capture address resolution protocols, everything. You got my point. So this is actually the display filter that you could use to capture packets. Or you, for example, based on the IP address, if you uh, uh, want to capture traffic of this interface, this IP address, you can collect, for example, or different protocols, whatever way you want, where you would like to. Okay. So this is a display filter. Now this one you see here, this lists down this part actually lists down all the packets, for example, okay, that are being captured. Okay, so you can say, for example, it just lists down all the packets. Okay, now here, for example, I showed you command menus, filter to use. Now, here you see another thing that is very, very important is I would like to show you here, for example, different things. On frame one, for example, so what is this about? I told you if you have not yet covered OSI reference model, I would strongly suggest to go through another video, basics of networking. Okay, and you will be able to understand these concepts. Now, what I'm saying is, practically, you should be able to see how different packets are going through the interface. So if I'm clicking this frame 01, frame, what does it mean? On which protocol, on which layer, for example, this protocol is working. This frame, if I could increase the size of this, for example, let's see. So now this frame you see here, 100 bytes on wire. So this actually represents physical layer. Okay. So physical layer, we are capturing 800 bits of data, for example. Okay. On interface any, because we have not defined any interface, and ID 0. Here, there are different things. I would say here, another important thing is an encapsulation. This encapsulation means wrapping up the data with the header. So if the data flows from sender to receiver, of course. So from sender, for example, when the data is going, this process is called encapsulation. So from application data, so that the data will pass to the presentation layer. Presentation header will be stamped on it, for example. Similarly, when it is passing through the physical layer, okay, all the headers will have their headers appended on that particular packet. This is called encapsulation. So the same packets, the same headers actually are removed at the receiving end, which is actually the process of de-encapsulation. Fine. So now here you see here the rule is ICMP, for example, the different things. These are all related to first layer of OSI reference model frame. Okay. So here you see here all the timings, time data, blah blah blah, collect, yeah, everything. So for example, on the second layer of OSI reference model here, okay, so you see here this layer. I told you that on layer 2, you will be able to find only, MAC addresses. So machines are talking in terms of MAC addresses. So here you see 08002027 FD. So this is MAC address, okay? And they are I told you about unicasting. It's one-to-one communication between different machines, between two machines. Link layer address protocol, Ethernet 1 we are using, for example, and these are different things related to layer. Now, on layer 3 of OSI reference model, we are working on IP addresses. All the devices, layer 3 devices, when I say it means routers, they are working on IP addresses. Okay, so here you see we have IP address 4, version 4. This is IP address 192.168.54.3, for example. This is IP address. Okay, so they are on the layer 3 now. We are on the layer 3 now, and the source address is, because we pinged from Ubuntu, so the source address is 192.168.54.3. The destination was file, which is our Kali machine. Okay, and here you see different things, packets, how they look like, version 4, differentiated services, and identification. These are different flags, you should be able to see. And also like here, the source address 192.168.54.3, it is evident that the communication is happening between these two machines. Okay. So now, then we have ICMP. ICMP actually is a kind of layer 4 protocol, not between, runs between layer 3 and layer 4. Okay, so it's just to check the connectivity between the machines. So here you see you have different, different fields that you can explore. For example, then you have here the data. Okay, so the data looks like this. Fine. So which means we are good to go. And here I had minimized it earlier. So here you can see different packets displayed. Here you see all the data. For example, if you hit this one, it contains this timestamp. Okay, if you click, for example, IP address here, for example, you should be able to see part of this IP address. Okay, all encrypted. And time to live, contains this byte contains this time to live information. So this way, we are able to capture the traffic. Now, the point is, if you want to capture the protocol of ARP, what is this ARP? Address Resolution Protocol is the protocol that maps the internet protocol, IP address, to media access control. Okay, to MAC access control. So the point is, layer 3 device needs to communicate with layer 2 in order to effectively communicate, right? So these layer 2 and layer 3, because they speak a different language, how will they understand? This protocol helps us to, translate IP address into MAC and MAC into IP address, right? So here ARP helps to find the MAC address of a host from its known IP address. I want to show you here, for example, if I stop, let's say here, for example, yeah. So if I stop, yeah, here, if I do ARP space minus A, you are able to see here, 4 IP addresses, you see. So 10.0.2.1, this is actually the router's IP. We can double check this. Route space minus n. So if we do this route space minus n, you should be able to see a complete route. So here we have 10 dot, yes, it's a default gateway, and it belongs to this network. Then we have another network 54.0, and which is on Ethernet 1. Fine. Now, clear. If I do ARP space minus D, it means I'm deleting all the entries of ARP space, ARP, okay, address resolution, so that it should ask, right? So when you click this ARP space minus D, sudo ARP space minus D. ARP need host name. Okay, ARP space minus A, yeah. Okay, fine. We have this, and we clear this, for example. Okay, now what we can do, for example, we can check the different data captured. Okay, so here, for example, if we see ARP and hit enter, we should be able to find, for example, the traffic related to this particular protocol. Okay, so if I click the very first packet that is captured, for example, if I stop it now, okay, if I stop it now, the very first packet that I captured, for example, so you see here, this protocol actually asks, if Increase this. This protocol actually asks who has 192.168.54.3 because it has to create a ARP table. Okay, and tell 192.168.54.5. So it is asking Kali who has 192.168.54.3 IP address. Fine. Now, this one, 62, this another packet of length 62. This is a reply. Okay. And here it tells 192.168.54.3 is at. So these are MAC addresses. This is MAC address, this is IP address. So they are, they are translated to tell, okay, 54.3 is on this particular MAC address. It has this particular MAC address. Okay. So similarly, 10.0.2.3, where is it located? ARP is asking, okay, and it is asking this 15, okay, 2.15, which is Kali machine. So it's saying it is located on this MAC address. So you see, for example, this ARP protocol translates between MAC address to IP address and IP address to MAC address. It maps them. Okay. So this way, we should be able to understand the difference between IPs and MAC addresses. So now, we have ARP address protocol covered. Here you see again, first layer, then second layer, and ARP is a uh, is works on the top of the second layer and below the third layer. So here again you see our ARP MAC address, the game of MAC address, and this address resolution protocol you see here. So it works in between layer 2 and layer 3 of Wireshark model. Fine. So then, for example, what if we check here DNS? Okay. So you see here we have DNS data as well. DNS is domain name naming service. Okay, and domain names naming service is like it translates between human readable domain names. So you, for example, humans cannot remember IP addresses. How many IP addresses would you remember? It's difficult. So the point is we should have something human readable or human memorizable data. So for example, you have www.google.com, let's say here, for example, if we have, we are here, just giving you an example. So when we ping, for example, -3, let's say I'm just pinging with 3 3 times www.google.com. So you see here, because we can remember google.com, it's perfectly fine, but will you be able to remember this IP address? Okay, so 216.58.204.132. It will be extremely boring, it will be extremely difficult. So this is where this DNS server, this DNS service comes in. Okay, so DNS actually translates between human readable domain names to IP address. Okay, DNS is often called, let's say, the phone book of the internet because it allows users to access website and services by using easy to remember. You see, I wrote google.com, which is easy to remember, instead of long and complex IP addresses. You got my point. So this way, this protocol we can capture, using this protocol we can capture the data related to DNS. Okay, so here, for example, you see we have all the DNS related packets captured. Source is 10.0.2.15, and this is how the packet looks like. So if you click DNS, for example, you should be able to see across different layers. Okay, so this DNS actually works on the fourth layer of a reference model. So here you see you have another added entry of user datagram protocol 59658 destination port 53. So these, for example, the first layer, again, the same information, the data that was captured on wire, okay? The time, the delta, epoch arrival time, everything. Second, you will find, the source address, MAC address, I would say, and the device name if you want, for example. Okay, and on third, you will be able to see, IP related information. So source address, you should be able to see destination address, you should be able to see different this will become a theoretical class if I explain everything. So uh, at this point, it's sufficient enough to know that these points they actually refer to different layer of voice reference model. Okay, so user datagram protocol, we discussed it already. If you have forgotten this user datagram protocol, I would say in order to refresh, you should access this video on basics of networking. Okay, user datagram protocol where I explain the difference between UDP and TCP. Okay, so this way we can capture DNS data, DNS related traffic. Okay, now the next step is what is, for example, ICMP control message protocol, Internet Control Message Protocol. So I showed you, you can capture ICMP related data if you write here simply ICMP. Okay, you should be able to find all the ICMP related packets. Fine. Now, ICMP is a network protocol that is used to send error messages and operational information between. This is what I already mentioned. ICMP can also be used for diagnostic purpose. Yes, if I'm not getting any reply from my machine, for example, I would say it's not connected or there is an error, for example. Okay. So ICMP protocol is also a very important protocol to understand. So here, for example, you see all the packets are captured from this protocol. Now, how to filter by IP address? So simply, here, for example, in this display filter, you are using different protocols, ICMP, DNS, for example, or HTTP. Because you have not yet opened HTTP, there will be no packet at all because you have not yet captured anything. Okay, so if you want me to, for example, give you a test, what I will do, for example, I will open here browser, let's say. I'm not sure if it is working. Yeah, here, for example. So because yeah, the internet is, because I am using a proxy. I will explain you later. So I would not be able to use this at the moment. So you will not be able to capture HTTP, but if it was internet, for example, you could have easily collected, easily, captured the packets as well. So this is how, you can play with these packets. Similarly, for example, if you want to use another filter, let's say this one, okay. So this was my source address, 10.0.2.15, right? If you click this, you should be able to find the data related to this, this IP address. So you see here, source 10.0.2.15, it used the DHCP protocol, Dynamic Host Control Protocol. So actually, I told you that, we just assigned an IP address 2.15 on the Kali. Then, there was a DHCP server on this Kali, and it is used to connect, whoever is going to connect with this machine, for example, this will aid. Okay, this will be assigned an IP address using DHCP. Similarly, you see here we have traffic on this interface. We have been collecting DHCP related acknowledgement requests, DNS related data, everything. And for example, if I could use another IP address, because maybe, yeah, this one, you remember now what was the IP address? This IP address actually is of Google. So we didn't capture anything about this at the moment. So let's try to capture. So www.google, sorry, ping, if I would say ping minus C3 www.google.com. So here, for example, in the previous package we didn't capture, but if I run it again, continue without saving, it should be able to capture. Just a second. You see, so we are able to capture this protocol from this IP address as well. So you see here 216.58.29.209.36 is actually the IP address of Google. Okay, so now you see there are different fields. These are different timings, for example. Okay, at what time this packet was sent or received, the type of the packet. Okay, was it a request? Was it a reply? Like here, for example, for this packet, it was generated from 15 Kali. It was it was sent to google.com, for example, using ICMP protocol, and the length of this packet was 100 bytes only. Okay, so echo exactly this. So this data was sent, and the time to live was 64. And these are sequence number as well. So you see here, sequence number means like it will ensure provide you reliability. Okay, how many packets were lost in between, for example, you will be able to know. So this way, we play with this device with Kali, for example, you can capture traffic of different things. So this is what I have showed you. Let's capture we captured the traffic of IP address, another IP address. So this way, you can play it with this tool. Now, in summary, what we have learned? In summary, we have learned about the basics of communication and network analysis. Why do we even need it? How to use Wireshark to capture and analyze network traffic. Okay, so we have now captured this traffic, for example. We learned how to install and run Wireshark on Kali. We demonstrated some examples of network traffic protocols, such as I showed you ICMP, I showed you TCP, DNS, I showed you DNS, I showed you HTTP, not show you HTTP, I showed you DHCP, but DHCP here, for example, yeah. So you can stop it, for example, and here you can DHCP. So it will show you all the packet capture. Okay, it's like this. So we discussed these packets, and we discussed also some fields here in this panel as well. And okay, and we discussed some applications and benefits of network analysis. Like I told you why doing this is extremely important in security perspective, from troubleshooting perspective, and from optimization. So I really hope that you have enjoyed this presentation and learned something new. Thanks for watching, and if you have any questions, drop me a message on comment, please. And don't forget to hit like. My name is Dr. Ataullah Buriro, and I'm your host on the Cyber Guardian Academy channel. Today, we intend to perform a hands-on on introduction to Linux from ethical perspective, okay? So without wasting our time, I would like to start with the outline. So on one side, you are watching the presentation I have created for you. On the other side, I have run a script which is running multiple commands. So we will go through them each one by one. But before we start, I have an outline for this presentation, and the outline is like we will start with introduction to Linux, uh, who developed Linux and what is it for example. Then we will discuss features of Linux. Some distributions of Linux we will also discuss, like Fedora, like CentOS, for example, and Red Hat. And then we will discuss why Linux is extremely important from ethical hacking perspective. We will practice some Linux command, and at the end, we will conclude with a summary of what we did today. Okay, so here we go. Introduction to Linux. Linux is an open source operating system. When we say open source operating system, it means it's completely free, and you could download it, you could modify it, and you could distribute it. Okay, and this system actually was developed by Linus Torvalds in 1991. Okay, and this Linux provides a customizable and secure alternative to proprietary systems. Okay, so this is, as it is an open source, it is still competing with the proprietary systems. Okay, and Linux is used across multiple devices. Okay, from personal computers, from smart watches, even smartphones, to high-end devices like supercomputing machines, for example. So Linux is everywhere, okay? And it has distributions for every device. When we talk about features of Linux, Linux is an open source, like I already said. It means it is completely free of cost. Okay, so you could simply download it from their website and you can play, you could modify. Also, they have shared their code repository as well. If you want to contribute to that repository, you could also go and contribute. Linux is flexible. What does it mean? It means that it could be used on watches, on digital equipments, and supercomputing servers. Okay, and it has a lightweight infrastructure. When I say lightweight infrastructure, like if you remember when we were installing Kali, Metasploitable, or Ubuntu virtual machines, okay, it was hardly requiring 4 GB to 8 GB hard disk. Okay, I told you for one of my virtual machine that it is a very small virtual machine. It's a very light machine, so it doesn't require more than maybe 4 GB hard disk. Okay, so it's a lightweight resource. Now, GUI, those for GUI lovers, for example, Linux works exactly the same way like, like GUI based operating systems work, for example. So in Kali, I will show you like how GUI works, for example. But CLI is also, is the most preferred way of interacting with these systems. Now, distributions of Linux like has multiple distributions, multiple families, and the main important thing is each distribution has its own set of packages and updates, like Fedora, Red Hat, CentOS, Debian. These are all examples of distributions. Okay, and sorry, yeah. And now, why is it important in ethical hacking? Linux is actually a preferred operating system among ethical hackers. I have shared here a link which says this. Okay, so it's a preferred choice of ethical hackers. Why? Because 90% of the hacking tools that are available already in the market are written in Linux. Okay, so Linux provides a robust set of network utilities and support for powerful scripting languages like Bash and Python have the support of these languages. I will show you some commands related to Bash as well. So we will see. I mean, this is main point that it has the support of Bash and Python languages, for example. We can use it. But the main fascinating thing is 90% of the tools that are available are already written in Linux. So we have a point to go. Now, let's quickly check some file commands. Okay, so now I want to give you an introduction to all these commands that could be used on Linux systems, for example. So if I divide them into multiple, if I classify them according to their usage, there are multiple usage systems. For example, I can divide them in file system commands. I can divide them in system manipulation commands. I can divide them in file manipulation commands. I can divide them from networking perspective. I can call them networking commands. If I divide them from processing point of view, I can say process management commands. So I have created some slides for each of these classifications. Let's go one by one and cover what does this mean. So I'm supposing now that you are beginner and you don't know anything at the moment. Okay, so what I'm doing is I have the very first command that I'm running on Kali. Here I have Kali, you can see. And on Kali, the very first command that I'm running is clear. Okay, because in Windows it's CLS, for example. So I'm here. Now the very first command that we use, for example, after clear is ls. Ls, what is ls? Ls means list the content of the directory. Okay, and if I issue here ls space minus al, it will return me all the commands, all the directories that are inside it. Okay, so those starting with D represent directories. Here, D directories. And this minus, for example, at the start shows that this is a file. Okay. So this is first command, which is called ls. Secondly, for example, we can again clear them. Now, another point that I would like to mention here is there is a manual for each command. So if you write here man and you write, for example, ls, so what it means? It means you are asking to provide you the manual of usage, how to use this ls command. Okay, so if you press this man, you see you are getting a lot of description, lot of data, a lot of information from this command. Okay, so if we read this description, it says It lists the information about the files, the directory by default, current working directory by default. Sort entries alphabetically if none of this is specified. Okay, if you don't use any options, these are different options. You will check them, for example, in 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 uh, in later stages. Also here in the slides, if you see after before sorry under this syntax, if you see ls in bracket, you see options. These are the different options that you could use there. Okay, and then the file name. So ls space minus a space, for example, file will generate, or directory, for example, will generate the content of that directory. So this way, for example, if I press Control Z, I'm out again. So I do it clear again. And for example, if I want to check ls space minus L, let's say, and slash home, let's check what is inside this home directory. Okay, so home it's Kali. The same if we need to check inside Kali, what is it? So you can see bunch of things. So here you can see desktop, for example, documents, downloads, music, pictures, public templates, videos. Here you could explain, you could understand, the infrastructure of that particular directory. What is exactly inside this directory? Does it contains only files, or it has multiple directories inside? So I clear it again. Then we have, for example, if you want to create your directory by your own, for example, if I do mkdir, this utility will create a directory. Okay, so I want to create a directory and call it Buriro. Make directory Buriro. So here, if you do ls now, you should be able to see Buriro, which is here. Okay, and in Buriro, for example, uh, I go into the Buriro. So with cd command, cd Buriro, and here I can see there is nothing inside Buriro. So if I want to create a file, I would like to use touch command, for example, touch. And here I'm writing, let's say, info.txt. For example, I'm creating a file which is called info.txt inside this Buriro's directory. Okay. Now, if we check, we find info.txt. It is free. It has nothing. It has no content at all, but it's still there. Okay. So what if I need to copy this to the desktop? So if you check here pwd, we are inside home Kali desktop Buriro. Now if I want to copy this file to desktop, for example, how can I do it? I can use cp, and the file name information info text to home slash Kali and slash desktop, right? So this way, for example, I can copy. If we go to the desktop by cd, we are on the desktop now. Here you see you have found that file info.txt, which is copied from this directory of Puriro. Fine. Now, if I want to remove this file info.txt, I will use rm, okay, which stands for remove. So rm actually has removed info.txt. Let's do ls again. There is nothing. I clear it again. Let's say now let's go to Buriro. Okay, the directory named Buriro. We are here. PWD, we are in the home, Kali, desktop, and Buriro in the in the Buriro directory. Now what we are doing is we want to check move. Okay, so move is like a cut and paste. Okay, here we still have that copy of the file that we generated. Now we are doing move with info.txt to where should I move it? I will move it to home slash Kali slash desktop. Okay. Now with move, remember from information info.txt file from here will be removed. Okay. So now if we check ls, we find nothing, right? It means the file has been moved to desktop. So if we go to desktop cd double dot, we are in the desktop now. Issue this ls command, and you see you have information info.txt file here. All clear? Fine. So we have practiced list ls command, we have seen cd command, we have seen make directory, we have seen pwd, cp, move, rm, touch, for example, right? We have seen them. Now, if you want to remove the directory, okay, here Buriro, if you want to remove this directory called Buriro, rm Buriro, for example, rm space minus rf Buriro, it will remove the entire directory along with all its content, right? So we have nothing now. If you want to remove a file, you don't need to add minus rf. For example, you could use rm simply to remove this. Now we are all done. We have nothing. Okay. So this way, there exist multiple file system commands that you could use, for example, to play with it. Okay. Next slide is system information commands. Okay, these commands are important to understand how the system is working, right? So, for example, I clear it again. If I do uname minus a, for example, it will check me, which operating system I'm using. So, if you see here, it has Linux Kali. This is the version AMD 64. You can, and X60, 8664 is the architecture. Okay. So uname minus a will print system information, right? And if you want to check the host name, which is already Kali, you see you have a Kali here, okay? So this way, for example, we always see, okay, top, for example, this stop command displays Linux processes running. So let's see which processes are running. So you see here, these processes, these multiple processes, and this is for beginners, for example, this PID is the process identity, okay, number, that if you want to kill this number, for example, if you want to stop this process, you could use kill command or pkill command, for example, to stop them. Fine. So this way, we could check different processes. If you want to see, if you want to, display information and process, there is another way as well called PS. And in PS, you see here, you have again PID, okay, and you have which port they are running on, for example, and these are different commands, okay? Ping, man, pager, man, blah, blah. So I clear it again. And if you want to see, let's say, the CPU information, for example, on the system, you could simply use LSCPU. This LSCPU will provide you, all this information about CPU that is inside this machine. Okay, so you see here, CPU on mode is 32-bit, 64-bit. Architecture is this. Address size 39-bit physical, 48-bit virtual, and little Indian byte type, byte order. So, and 13th generation Intel or Core TM-i7 processor it has. Okay, so let's clear it again, for example. And if we use who, what does this who command will show? It will tell me who is actually logged on the system. Ari, okay, so this way, for example, you can play with these commands. Next command is, next classification is user and group management commands. In these kind of commands, you can manage multiple groups, multiple users. You can give them rights, give them privileges, give them, access to the resources that you would like to. So all these processes are handled under these commands. Okay. So simply, if you want to add here, for example, user add, no, it will not work without sudo. So I'm doing sudo user add, for example, and I'm creating a new account. Let's say I'm creating a new user called Buriro. Sudo user add Buriro. So Buriro is added, right? So now, for example, if I want to delete this, I could use, user sudo again, sudo user del Buriro. You see? Okay, so this way, for example, we can play with these commands like, for example, for password, okay, again with sudo password, this utility, this command is going to change the Linux password of a user, okay? So sudo password, for example, and Buriro, but Buriro is not here. I want to show you again. So sudo, for example, user add Buriro. We have added a user called Buriro now. And we are assigning a password to this user. Sudo username password to Buriro. new password. So I'm doing, let's say I'm using 1234 as a password. 1234. Okay, password updated successfully, right? So now, for example, you could use, uh, you could change that user, for example, and you can play with it. Okay. So this way we have multiple utilities available. But now if you want to remove this, for example, sudo or sudo user delete and burrito. So you have removed the user. Fine. Now let's check groups, for example. So if you want to add group, what will you do? So you will use group sudo again, sorry, sudo group add. Let's say I'm adding a group called finance. Okay. And in finance, I will have multiple users. Okay. So user group add finance, and I can add different groups, different people here inside this group. Okay. And then, for example, I can assign the password to every user of that particular group. Okay. So for example, if you want to remove this, okay, and group del finance, okay, so it will be removed. The main point is, if you want to understand all these things, you could simply, whatever command you want to use to understand, for example, you can use manual, okay? Man space group aid. So it will give you all the details related to, about related to this command. So you can understand from the description that lists that says that the group aid command creates a new group account using the value specified on the command line plus the default values from the system. So this way, and you can understand the options as well. So you see here minus F, minus H. If you want to do, for example, minus help, group aid, if you do minus H, it should provide you the help related to creating the group, right? So this way, for example, we can play with these commands, okay? You can go and practice. Similarly, in next classification, we have file manipulation commands. Like I showed you already, for example, we used touch command, touch info.txt, for example, to create a file. Now we have a file here, info.txt. If I want to create a file called, let's say, uh, score.sh, I'm opening it with a editor called Nano. And in Nano here, for example, if I'm using, let's say, hello world, I'm just writing hello world here, for example. So Control O, yes, I'm saving it, and Control X, okay? So now if you change this, change mode, for example, because it's a sh command, score.sh, you changed, you could execute it now. For example, if I execute it with bash.score, okay, so I should be see here hello, okay? So command not found. Score.sh, yeah, it doesn't have a command inside. So but the point is, you should understand that uh, simple commands could be created using touch. You could create commands using editors as well. Okay. And similarly, you already saw make directory, remove directory, copy from directory, move and move from a directory. This way you can play with these commands. And the next important thing in classification is network commands. So in my videos, you might have seen already that whenever I open a machine, I just check IP addresses and all these things. So the very first thing that I see, for example, on Kali is ifconfig. It will provide me the IP address, the network interfaces parameters. Okay, so if I want to see the network interfaces of all available on Kali, let's say I would say if config, it will print me three different interfaces that it has. So first interface is ETH0. So here are some interesting things that I would like to mention here. On this interface allows a maximum transmission unit of 1500. Okay. And its IP address is 10.0.2.15. Okay. and its net mask is 255.255.255.0. Okay, if you want to understand these IP addresses, I would suggest you to go on the basics of networking, my other video. I will share here the link as well, and you will understand these things. Now, the point is here, the IP address is 10.0.2.15, which means it has a subnet mask of /24. Okay, and the broadcast address is this. What I mean by broadcast address is this is a broadcast address used among all the devices on the network. And this IP, for example, could never be assigned to any host. Okay. So this way we have another interface as well, which is called Ethernet 1. And mind you, here you see different networks. 10.0.2.15 represents here a NAT network, which actually is connected to network address translation, because I needed internet on this machine. So it's this call is connected to NAT, and NAT has given this IP address. And then I have another interface. On that interface, I have a virtual adapter, or a host only adapter, and has this IP address 54.4. Mind you, for both these interfaces, the subnet mask is /24. Okay. And this is loopback IP. No need to tell you, because you know about this thing. This is a loopback IP address used to check its own connectivity. Fine, we are fine. So now, for example, if you ping, what I do, for example, if I want to connect, if I want to check the connectivity between the multiple devices, I would use ping utility. Ping again, if you want to see its help, for example, manual ping. Okay, it will give you the manual of ping command. So there are multiple options here. You could see, for example, here -c count, it means you want to send, let's say, a fixed number of packets. Let's say I'm interested to send only 10 packets, let's say. I would use this option and then followed by the number. It will send exactly the same number of packets. Okay, so this way you can play with these options, for example, and you can also, create like larger networks, larger packets as well. So Control Z again. I'm clearing it again. So what I do, for example, I do ping www ping minus, let's say, 3 minus c 3 only 3 packets will be sent to the to the machine that I want to check the connectivity. 10.0.2.1. So where is this 2.1 come? If I show you route space -n, you should be able to see here three networks. Okay. So the gateway is 10.0.2.1. This gateway is actually the interface that is connecting this Kali to the internet. Okay. So 2.1, for example, is the gateway of this and for this network. And it has also another network 54.0, and which is not connected to internet. So it doesn't have a gateway. So now if I could check ping -c 310.0.2.1, let's say, it should give me reply. Okay, so and I get the response from all three packets. So there was a 0% packet lost. Basically, this ping utility is used in the ICMP protocol. Probably I will cover that topic as well in later videos. But at this stage, we should understand that if we are getting the replies and the packets are not lost in the middle, it means we are connected. Now, if I could ping, let's say, whatever, let's say, for example, ping -c3, let's say, and www.google.com, let's say. Okay, I'm trying to ping google.com, and all the ping packets were successful, so it means I'm connected to Google. Ping -c3 www dot, let's say, facebook.com, for example. Yeah, we can ping each other. Okay, so it means we are connected to internet. Now I'm clearing it again. Similarly, we have multiple commands. Like here, you have seen ifconfig number one. Number two, you have seen ping. Number three, you have seen route space -n. Number four, if you want to see net state -a, okay, this net state will give you, give you back the name servers, for example, interactively. If you want to check net space here, okay, Not state, for example, you see here, multiple ports are connected. If you, again, I would say, if you are interested in learning all these things, you could simply type, that manual with netstate, you will be able to see. Now, here you see, for example, protocol is UDP, okay, and here you have local address. So on from 10.0.2.15 on port number this, okay, you are establishing a connection with this, okay, and with this. So all the connections are already established. Perfect. Now I'm clearing it again. You have another important command which is called route, which we have already seen, and TCP dump also work or no? I wanted to just double check. Okay, TCP dump teacher, you don't have permission to perform. Okay, we can capture. TCP dump actually is used to dump the traffic on the network. So but probably you need to give also the the port number as well. So if you want to read the detail of this TCP dump, again the manual, the magic word manual, this TCP dump prints out a description of contents of packet in network interface that matches the Boolean expression PK filter. So it can work like Wireshark, for example. So we will check in the next videos how to capture all these traffic. So basically, we can use multiple commands, network commands to monitor the network traffic, to capture the network traffic, to manage the network traffic, and so on. Okay. IP tables, for example, you could also use IP tables space minus L, let's say. Okay, so here could not fetch rule generate permission denied. Sorry, sudo IP tables space minus L. Okay, so here you should be able to see your routing table, for example. Clear. LS, clear again. Now, similarly, now is the time to understand process management commands. Okay, one command I already showed you, maybe two commands. I showed you PS. It will give you back, all the information about processes. For example, if you say PX ops, it is not working. So PSZCH, for example, the ZSH, the very first. Okay, so here you see, you can get the information about that particular process. Okay, clear again. If you want to understand, for example, other Linux processes, you can use top. Top should be able to print all the processes that are running. Okay, okay. Similarly, for example, clear again. So you have, I showed you PS, ZSH. This, for example, no, PS. If we enter PS, yes, of PID. So PS 1484. Okay, PS 184. If you want to see only this, for example, you can use this command. Okay, it will print the information related to this command, this processes only. But if you want to stop this process, for example, p kill or kill, maybe kill, and the process ID 1484. Okay, it is killed. Now, if you want to see 1484, okay, ls, sorry, ps, okay, it has started again. But since it's a system process, it will start running again. So clear again. And this way you could use multiple commands, okay, for process management. Then we have archive commands. So sometimes when we download, for example, some tool, let's say, and it's in zipped format or in EZ format, what we do, we can unpack the contents of the downloaded file and we can save and install them, right? So, for example, don't worry, you can download that any packet in any format that you want to have. For example, download it and then you have the option unzip the content of that file that you have downloaded. Okay, so normally we use star, for example, to to open the archive utility, for example. So here I don't have any file to install, but we can run here, for example, manual. And if you want to use tar, it will give you, tar here, then the options. Okay, if you want to create a archive file, let's say tar minus minus create, okay, and tar minus t, tar minus x, v, z, f. There are multiple options. Okay, you can play with them. And the description says GNU Guitar is an sorry, tar, not guitar, is an archiving program designed to store multiple files in a single file. Multiple files in a single file. So what you can do, for example, you can compress multiple files together to create just one zip file, archive file. And to manipulate such archives, like you can copy them, you can, send them somewhere, or you can unpack them again. So there are multiple options. Here, there is an example. You see, I want to open tar here, tar cvff cfv etc.tar slash etc. I want to open this etc.tar in the directory called slash etc. And with these options, cfv, you need to see what does this cfv means. Okay. So from these, you can understand. Now, back to the topic again. So you can use tar, gzip, gunzip, zip, unzip, tar.gz, tar.bz2, tar. These are multiple utilities. Some of them they are not listed here as well. But could be many commands to archive or unarchive, the files in a Linux. Similarly, for connectivity creation, let's say for remote access, for example, there exist multiple commands like SSH. Okay, and for SSH, you need to have a key pair, right? So SSH with keygen, for example, you can generate a pair of keys. Okay, then for SCP, for example, it's a secure version of copy CP command. Okay, you could securely copy using port number 22 and SSH protocol, securely copy the data from remote server to your computer, for example, locally. And secure file transfer protocol, SFTP, okay, it's a secure version of file transfer protocol, FTP. You could use this command, for example, to download, securely copy any file from server to your local machine or from local machine to your server. And SSH add, you could add SSH, user, for example, or you could manage SSH agent. You can play with these, for example, SSH agent. Let's say if you want to see the detail of this SSH agent command, you should see SSH command is a program to hold private keys used for public key authentication. Okay, through use of environment variables, the agent can be located and automatically used for authentication when logging into the other machines using SSH. So this way, I mean, you could play with them. Okay. Okay, now there exist some techniques to automate the process. Like if you remember when I started this video, you were able to see, a script running on Kali, printing multiple things. Okay, what does it mean? How did I do? So what I did, for example, I created a script. Let's say, let's do ls. Here you see script.sh. I have a file called script.sh. I can very quickly take you in. If you want to open this, we can open it with nano and nano script. Let's say, okay, now here you see I have added, some commands here. So you see uname space minus a. Now you know it will print you the detail of the operating system installed on your machine. Okay. And net state, you know that it will give you the status of network, for example, on your machine. Then you have route space minus n. Then you have ping minus c. Okay. Here ping minus C, if this is 10, it means it will send 10 packets to this address, for example. ARP space minus A, it's a address resolution protocol work on layer 2 and converts, the MAC address to IP address and IP address to MAC address. address resolution protocol. Then we have again this net state is repeated. Then we have ping. I wanted to send 1000 packets to facebook.com to check. So, and ping 500 google.com. So it was sending multiple packets to Facebook and Google. For example, I was playing with them. So this is a .sh file. I call it shell scripting. And when we control O, yes, we saved it. Control X, we are out. Now, just to show you quickly how to run it, you can run it using, for example, bash and score.sh, okay, or script.sh here. It should be able to show you the output. Now you see every command you have added in that particular file is executed, and you give the rest, you get the response from these servers that you want to connect to you or the command that you want to use, for example. Fine. So next is yeah, this one we already did. SSH you can use, for example, to secure to connect to the secure client. For example, if I want to connect from this machine to the server on the network, let's say I would use this command ssh dot at the rate username first at the rate example.com or any website.com. Okay, so these we already checked. Shell scripting commands we have already seen. Now system maintenance command, the very first important things that we forgot, for example. So if you want to install something, let's say, uh, I would say sudo apt get, the very first thing that I do, for example, I update. Sudo apt get update, okay? And what does it mean? It means if there is an update at the backend, for example, bring those updates to me and install them on this computer, okay? So every component which was updated, for example, will automatically be downloaded from this website and it will be installed on my machine. Okay, so this way you can upgrade your operating system, upgrade. You can download any software and install it. For example, sudo apt-get install using this command, for example. And using different distributions like yum, for example, you could play with yum install with any package here, for example, that you could see. This way, you can actually play with these system maintenance commands. Okay, so if the package is Debian package manager, you could use this command dpkg-e package.deb, for example, to depackage it. Okay, and then you can install it. Okay, similarly, yeah, so these were the last set of commands that I showed you. In summary, if we just revise what we did, for example, so I'm running this script again just to be happy. So Linux, just to summarize, is an open source operating system. When I say open source, it means it's free of cost. It could be used, it could be modified, it could be distributed free of charge. Okay, and it was developed by Linus Torvalds in 1991. Linux is available in multiple distributions, like I showed you, in Red Hat, in Fedora, CentOS, Debian. There are multiple distributions available. Linux is extremely popular among hackers. Okay, as I gave you in justification saying that 90% of the hacking utilities actually they are developed in Linux. So this is ultimately the first choice of ethical hackers. Okay, we played with some Linux commands on Kali, and we checked their outcome. We checked everything. So thank you so much. If you have any questions, write me in comments. I will try to answer to the best of my knowledge. So thank you so much again, and see you in the next. Thank you so much again, and see you in the next video. Bye for now. Hello, Cyber Guardians. Today we are starting Module 2, Basics of Ethical Hacking course. And in this video, I'm going to present information gathering. Why is it important? what are the techniques that we could use, what is the impact of information gathering in cybersecurity, and we will discuss some best practices as well. So let's get started. I will, this is the outline of my presentation today, and I will start with the formal definition of information gathering and what is its significance. Then I will talk about some techniques that are already available in the market. For example, OSINT tools, we can exploit those tools to gather information. Social engineering, web scraping, network scanning, reconnaissance, these are different techniques that could be exploited to gather as much information as possible about a target or a target organization. Then we will discuss some advanced information gathering techniques. Okay, and I will talk about some tools as well. Okay, basically, in advanced information gathering tools, they combine, multiple information gathering techniques like web scraping, OSINT tools, for example, to perform high level or advanced information gathering. Then I will show some commands that we can run to gather information about a target organization, let's say. And in the end, we will discuss some best practices for information gathering. Okay, so stay tuned. Let's start it, and I will conclude with the summary of this presentation. Thank you. Let's start. Now, what is information gathering? Okay, formally, we can define information gathering as the process of collecting data and intelligence about a target. This target could be a single person or an organization, small to medium or even large organization. Okay, so it involves this process of information gathering involves network scanning, website scanning, or individuals scanning for individuals, for example, using different tools to assess vulnerabilities, identify weaknesses, and plan cyber defense or offense strategies. I will talk about these two in detail. What is cyber defense and what is cyber offense? Okay. So information gathering is equally useful, is equally important in defending your organization or launching a offensive cybersecurity towards organization, for example. So information gathering is extremely important in both the cases. What is cyber defense? I'm collecting information gathering. I'm doing information gathering for defending my organization. Or for cyber offense, for example, I'm gathering the information to launch an offensive attack on some organization. Okay. So in both of the cases, the objective is to understand the target environment. Okay. Target environment better. So like operating system, like applications installed, like tools installed, like vulnerabilities, like open ports, everything. Okay. And identify potential vulnerabilities. Okay. Or weaknesses that one can exploit. Okay. So let's explain this cyber defense first. In cyber defense, actually, information gathering helps in identifying, okay, and assessing potential security risks and vulnerabilities within an organization's network or infrastructure. Okay, so before an attacker might attack my system or my network, I would be able to know, the weaknesses of my loopholes in my organization, the weaknesses or vulnerabilities that one can attack, one can exploit. Okay, and this information gathering will enable me, for example, to take proactive measures, actually, to strengthen the security posture, okay, and to mitigate possible potential attack, for example. In cyber offense, for example, the point is very clear. You are provided with using information gathering, of course, valuable insights into the target system. So what is this system about? Okay, how many IPs or networks they are actually connected to, for example, who are the people that are working there, for example. So you can collect all this information to launch an offensive cyber attack as well. Okay, and this information gathering basically forms the foundation of launching. So this is extremely important. So information gathering is considered as the first step towards hacking. Okay, be it ethical hacking or be it non-ethical hacking. So attackers, they try, for example, different take kind of attacks like social engineering. For example, phishing is a very important example of a social engineering attack. Idea is to trick a person, for example, to click a link. That link is malicious, and in order to get the information about that person or about that system that he's running on, for example, that application, we can actually learn what was he doing or what programs he is working on, for example, and we can get his sensitive data. Or network intrusion, for example, like what looking for open ports and then exploiting those vulnerabilities and getting into the system. And intrusion, a successful intrusion could have consequences, like very hard consequences, to be honest. So this information gathering plays a vital role in both cyber defense and cyber offense strategies. And why it matters? What is its significance? Okay, when we talk about significance, I told you that information gathering is actually the first step, you know, and there are different impacts, okay, based on different steps that you take in this first step. So, for example, you could conduct reconnaissance. Okay, what is this reconnaissance? Reconnaissance is basically the process to identify the target characteristics, capabilities, and vulnerabilities. Okay, so once you are done with this identification, let's say, you can actually start performing vulnerability assessment to see, you know, how these vulnerabilities, okay, could be exploited to gain the illegal access, for example, or illegitimate access. And then you can generate threat intelligence to anticipate and respond to emerging threats and incidents. This way, you can actually harness your system. You can make your system more, your organization, your network, or network organization, for example, you can make it more secure. Now, what are the goals of this information gathering? Okay, so basically the first goal is to find and exploiting the weaknesses. Weaknesses, if I'm looking for weaknesses of my own organization, it's always good. Or if I'm hiring someone, for example, to look for those look for those weaknesses and tell me, for example, it means I'm hiring ethical hacker to do this. Okay, but in any case, it will be extremely important to find and exploit those vulnerabilities. Second goal, for example, could be gaining unauthorized access to the target's data and resources. Okay, so this basically, you know, this is more to black hat hackers, for example. Preventing or mitigating cyber attacks from external or internal sources. This would be my goal, you know. So I would be happy to prevent and mitigate cyber attacks from external threats. And again, also like improving our own security, okay, and awareness and defense mechanisms. So this information gathering is extremely important from all perspectives, okay. Now let's start information gathering techniques now. Okay, so what are the techniques, how this data could be collected? Okay, so first technique is open source intelligence, OSINT tools. This technique, by using OSINT tools, these are open source tools anyone can use, for example. And idea here is to access the publicly available sources such as websites, social media, blogs, forums, news, and everything to gather information about a target. Okay, so there are multiple tools available like Tracert, like OSI, like or Who is, or IAPinfo.info, for example. You can collect the information from for of different organizations on different platforms. And by using these tools, for example, we can find the name, man, most importantly, name, location, email addresses, phone numbers, and interests of a person or the domain name, IP address, services, and technologies of a website using OSINT tools. So these tools, they play a vital role. I will talk about these tools in the next slides. Now, another information gathering technique is social engineering. Okay, this technique, like I gave you an example of phishing as well. This technique involves manipulating or deceiving people into revealing sensitive information or performing actions that compromise their security. Okay, and phishing is the main main trick, that could be exploited to do so. So people can use social engineering to trick someone into clicking a malicious link or opening a phishing email or giving you their password. Okay, so yeah, this is social engineering kind of a thing. Then web scraping. So this technique actually involves extracting data. You might have used web crawlers or web scrapers, for example. So these scrapers, these crawlers, they extract data from web pages or applications using different tools or scripts. So one can write a script also to scrape all the information that is available on the website. And we can use normally web scraping is done to collect product prices, customer reviews actually, and conduct contact details as well from our website for recommendation purposes, for example. Okay. But in cybersecurity, this is also, most harmful technique. Then network scanning. This is most important from network engineer perspective or cybersecurity perspective. Network scanning means you are scanning an entire network to find open ports, which actually is the weakness. Open ports, service, protocols, and vulnerabilities. Using different tools, there are many tools that one can exploit. For example, I have written here as example Nmap, network mapping, Wireshark. Wireshark is a tool to capture packets, or Metasploit you could use. Okay, so we can use, for example, network scanning to discover operating system of the remote machine, remote target, for example. Okay, the version of the software installed and the page level of a system, or the type of and the service of version of service running on that port. So if the port is open, we can exploit. Now, reconnaissance, this technique involves observing or monitoring a target's activities, I mean the behavior of the target, behaviors or communications using keyloggers. These are advanced level attacks, for example, spywares or snipers. Okay, so these are five important techniques for information gathering. Now, here I write some tools I wanted to show you. So for OSINT tools, for example, I gave you example of Nmap. So there could be many, like Maltigo, for example, is a very important is a very important tool to collect information about the target. This target is could be an individual or could be an organization. Shudan is a most preferred web browser for attackers, actually. Google Docs, for example, you could use. So these tools allow you to search and analyze public data sources such as websites, social media, databases to find the information about an individual target or about a target organization. Okay. For social engineering attacks, you see there are many tools as well. It's like Metasploit, Set, Burpsuit, Phishing Frenzy, etc. etc. These tools allow you to create and launch phishing campaigns, fake websites, malicious attachments to trick or persuade a target into revealing sensitive information or performing actions that compromise their security. Okay. For web scraping, normally web crawling, for example, I would prefer doing it in Beautiful Soup or in Scrappy, for example, but there are some tools that you could exploit. These tools allow you to extract and pass data from web pages or applications using automated scripts or browsers. Network scanning, we can, in the next lab, for example, of this module, I will go through all these tools that I'm listing here. So we will be using Nmap, Wireshark, Metasploit. I will demonstrate you how we can gain control of the target network or target machine, for example. So these tools allow you to scan and probe a network of system for open ports, services, protocols. I will tell you like which ports are open and which services they are running. Okay, and which protocols they have installed, for example, and we will see for potential vulnerabilities as well. Okay, and for reconnaissance, I told you keyloggers, spywares, snipers, netkit. These are the examples of tools that you could use for reconnaissance. So these tools allow you to monitor or capture a target's activities, behavior. This we have already said. So now, what are advanced information gathering techniques? Okay, so basically, if I have to explain it, these are these advanced information gathering techniques, I would say. They are methods of collecting data from various sources. So not just one tool or one technique you are using. Here, multiple techniques. Data is collected using multiple techniques, and it is mapped through a single tool, for example, to see to extract the information and from various sources such as networks, websites, databases, social media, public records to support the objective of security. Okay, so for example, very first thing that I would say here is passive DNS analysis. And what is this DNS? DNS is a domain naming service, for example, and this technique could be used as advanced information gathering as well. So this process of capturing and analyzing DNS queries, okay, and responses to discover domain to IP mappings, domain ownerships, domain history, and malicious domains. They all come under passive DNS analysis. And there are websites, there are tools that actually do this. Okay. So then another technique is traffic analysis. This is extremely important information gathering technique. Okay. The process of monitoring and measuring the volume. So, you know, uh, collect all these records of normal data traffic and abnormal data traffic, you will be able to see a lot of difference between those traffics. Okay, so the process of monitoring and measuring the volume, okay, volume of upload, download, source, destination, and behavior of a network traffic, we can actually identify patterns, trends, anomalies, and threats. This technique actually, even the traffic analysis, we actually use as a researcher, for example. I use this technique to detect whether or not there is an intrusion going on. Okay, so intrusion could be detected using this traffic analysis as well. Next, fingerprinting. Okay, so the process of identifying and characterizing the features and properties of a target such as a device, for example. You can fingerprint a device, you can fingerprint an application, a user, a website, based on what they generate, what they expose, for example. Okay, so there could be many ways to do so. For an individual user, there could be different tool. For a website, tool could be different. But literally, we can fingerprint based on what they generate or what they expose any device, application, user, or a website. Next technique is, yeah, if I'm talking about the tools that one can exploit, for example, for passive DNS analysis, there are tools like Passive Total, Risk IQ, Virus Total, okay, and these tools, I wanted to repeat here again. Like these tools, for example, use they could be used to query historical DNS records to identify past and current associations, tackling domain changes, and uncovering hidden and trusted. So I would strongly suggest to check their websites, passive tools. These are just the three examples. There could be many. Okay. Then for the traffic analysis, the basic, tool that I showed you in the last video was Wireshark. So from Wireshark, you can actually capture all the data packets of related to any protocol, related to any IP, source and destination, for example, or anything. Okay, so in traffic analysis, you could try TCP dumps or grow IDS, for example. And here also, the usage of these tools, for example, is about capturing and analyzing network packets to detect suspicious activities. So, see, these suspicious activities, mind you, could be caused by malware, or could be caused by intrusion detection, or could be caused by unauthorized access attacks. So idea is from the traffic analysis, to identify whether or not the incoming access attempt is a legitimate one or it's unauthorized. Then we have for fingerprinting, there are three tools as well: POF, Nmap, Netget. So by using these tools, for example, one can identify target system characteristics, including OS version, which operating system is installed on the target machine, service running, which service is running on which open port, and network configurations, for example. Okay, and to tailor attack vectors and evasion strategies. So let's now check some commands, I would say, that could be used to gather the information. Okay. So the very first command is ping sweep. What does this ping sweep mean? So this ping sweep means you can you can ping every machine on that particular network here, 192.168.54.0. So this is an entire network. Slash 24 means 254 hosts could be online here, could be up, right? So using this command, nmap minus sn 192, this is actually the example IP, so you can check for another IP. So it will send ICMP packets. Since it's a ping utility, it will send ICMP packet to send, you know, to send ping to every device and check whether or not that system is up or not. So it will start from 54.1, 2, 3, 4, 5, 6, and up to 254. And at the end, it will generate the output saying the scan is complete and there are like few machines or all machines they are up. So we will go through them once again. So NS lookup is also extremely important. We can find DNS related data query from this nslookup example.com. So this replace this example.com with your website. And we can check ports. Actually, this is what I was telling you about using nmap minus p minus this command, for example. You can scan all the ports on the specific IP addresses. Okay, and with this, for example, command, you can check, okay, service version or open ports, which services are running on which open ports. Okay, and web infra enumeration, for example, you could use widget or you could use curl, for example, to read. Curl is used to retrieve HTTP packets headers, sorry, and widget is used to download any curl. Now, for the second part, who is lookup? Who is extremely important command. We can use this who is command to actually get the data about a target. We can use email harvesting as well. Harvester minus D. We can play with these tools, for example. So at least we can have a rough idea how these things they work. Okay. So let's do some live demonstration. Okay. Okay, so here we go. Now we are starting live demonstration. And in this demonstration, I will show you some commands, for example, how we can run on Kali to find, for example, to collect information about a target. Okay, so here you can see I have uh, on one side I have the presentation, on other side I show you my virtual machines. I have Kali here and I have Metasploitable running it downwards. Okay, so on Metasploitable, let's say I know its IP address is ifconfig is 10.0.2.4. Just wanted to be sure. Ifconfig. Okay, so yes, 2.4. Now let's first ping it, ping minus c with two packets only, and 10.0.2.4. So here you see I have sent two packets just to check the connectivity. Okay, we are connected. Now, the very first thing that one could use, for example, is ping sweep. What does this mean? Ping sweep is actually a utility using nmap you can do, or you can do using simple ping as well. You can do what it does. It sends ICMP packets or ping packets to every available host on the network, okay, or any IP address in that particular network. Okay, and then if it receives the response, it will say, okay, this host is up. If it has not received any response, it will say it's down. Okay, so we can do, for example, nmap here minus sn. This is actually the syntax of command, and you can try using reading the manual of this nmap as well. Okay, So minus SN, and if you have doubt in any part of this command, you are referred to actually check the manual of this admin or take the help. Okay, so here 10.0.2.0, this is actually the network that my machines are connected on. If I'm if I click this, if I enter this, what will do? It will the scanning has been started as you see here, and it completed within you know yeah. So it has found three hosts. Just a second, I could here you could see three hosts, for example, and in these three hosts, let's try one more time. Yeah, and you see here you can check the progress of this as well. So nmap scan report of 1 4 15. Now I will tell you what is this 1 4 and 15. 15 straight away is the local IP address. Okay, so is the IP address of Kali. If you check, if you do ifconfig, you should be able to get this IP address on your ETH0, Ethernet 0. Then this 4 is your metasploitable. So these two machines are up. What is this 2.1? Where is it coming from? This is actually the gateway. Okay. So if you do r route minus n, for example, you should be able to get this IP as well. So this actually, I mean, this is a normal practice for me. I always put the very first IP as gateway. Okay. So now you have got the response from these three machines. So this scan tells you that uh, 1 is up, okay, and 4 is up and 15 is up. So only three machines. And nmap done because you have here described 24. So it says 256 IP addresses were scanned in this much time, and only three hosts were found. Make sense? Yes. Okay. So here we go. Now I clear it. And if we check, the open ports here, for example, nmap minus p, let's say minus p minus 10 dot, again, this IP address 10.0.2.0 should be replaced with 2.4, and there is no need to give the subnet mask. Now, what will happen if you run this command? It will start scanning again, and now it is scanning the open ports on Metasploitable. Okay, so all the ports on Metasploitable will be shown here. So wait, let's see how many ports are opened on Metasploitable. And this way, by clicking enter, for example, you should be able to see scanning time as well. How much time has, how much scan has been done. So now you should be able to see here these ports. TCP, this is port, and its status is opened, and its service running on is FTP. Okay, so these ports are open, ready to be taken. Okay, and if you, for example, right here S with V, okay, it should give you the exact versions of tools of softwares running on these ports as well. Just a second. So you see here these versions, for example, you see VSF FTP 2.3.4. This tool is, I mean, this software is installed of this version. Then for OpenSSH 4.7, we have Linux telnet. So you can basically, get all the versions of available services as well with this command. So similarly, we have multiple tools. I'm clearing it again, like who is, for example, who is also a very important command. Okay, so who is 10.0.2.4, okay, or it should give you, for example, all the information related to this particular IP. Okay, so who is 10? I have given the IP address of this metasploitable, and it shows that it has this range of 10.0.2.55 from, so slash 8 means it can accommodate in millions. Okay, so 256 multiply by 256 multiply by 256, the resultant will be the actual number of users or hosts that can be accommodated on this network. Since it's a private network, private IP address, for example, you could create a large network of these. Now, A lot of information you can see. Okay, also we can try on, let's say, Facebook, for example. So I need to find the IP address of Facebook first. So ping minus C and with 2 again, www.facebook.com, let's say. Okay, and I should be able to get the IP address of Facebook. Yes, 31 here. So if I write here, who is, okay, 31.13.86.36. Okay, so if you click enter, it gives you a lot of information. So you see here, this organization, actually this IP address belongs to Meta platform. And you see here, this is the net name, country, IE, maybe Ireland. Okay, and yeah, so a lot of data, for example, organization is this, admin is this, tech data is this, Meta, MNT, and yeah, Ireland, exactly. So it's in Ireland, and you can find some phone numbers as well, which is very, very important. Okay. So the point is, you can get a lot of information, okay, by using these commands. And there are many commands that you could exploit. So I would suggest you to go through these slides and practice. And in the next lab also, which is scheduled very soon, I will be practically demonstrating how we can collect as much information as possible using different tools like Harvester, like this Net Discover, like who is like ipinfo.info, for example. There are many tools I will show you in the next video. Okay, so now back to the topic, and yeah, I just minimize this. Okay, here we were. So these are different tools that one can exploit, for example, to to get the information related to the subjects. Okay. Now, best practices, when you are collecting information, you have to make sure that you follow some best practices to do so. And the very first, you know, best practice I would say is to acquire the permission and to check all the legal considerations. So whatever you are doing, for example, if you are collecting information about the organization like Facebook, we did, for example, okay, this was just a basic command, so I did it, but technically speaking, we have to have, permissions about doing anything, okay, on these platforms. This is extremely important. And once the data is collected with the cooperation of organization, for example, or permission, once the data is acquired, make sure that the data remains safe. Okay, so your network is safer now to hold that data or to ensure the integrity of the collected data. Okay, encrypt it, for example, save it somewhere very secure. Information sharing. So once you have collected this data, make sure that you share this information. This information is crucial actually. So for preventing widespread cyber attacks, so these footprints, they are extremely important for organizations to counter these attacks. And there exist some programs like AIS and JCDC as well, which where you can actually share the real-time data, okay, to mitigate the threat indicators. Most important thing, trust is extremely important. Okay, so try to establish the trust and ensure that you are trustable. Okay, and this trust, for example, will ensure that you will work for longer for multiple organizations and never share any data of one organization to others. Okay, establish trust among all the stakeholders that you are performing ethical hacking for. And training and awareness. So make sure that you share your findings with the professionals, for example, who are actually responsible to secure the networks, to secure to to strengthen their network, for example, and to check for responsible for their vulnerabilities, exploits, that so that they should be they should be able to remove all those problems or vulnerabilities. So this has brought me to the end of this presentation, and this slide, for example, is just to summarize what we did. So we defined information gathering and we discussed its significance in cybersecurity. Okay. Then we discussed some techniques like OSINT. This is open source intelligence tools one can exploit to gather information. Social engineering, and there were like network scanning, web scraping, or reconnaissance. There are multiple techniques. Okay, we discussed some advanced information gathering techniques as well, and we played with some commands and Kali. So I hope you have enjoyed this presentation. And now the next video will be on the demonstration of what we have learned for information gathering. So I will try to cover all the things related to information gathering in the next presentation, and it will be all lab, so there will be no theory involved. Okay, so thank you so much, and uh, see you soon in my next video. Bye.
Hello everyone and welcome back to Cyber Guardian Academy. Today, we're diving into information gathering, an essential aspect of cybersecurity and reconnaissance. So, what exactly is information gathering? Well, simply put, it's the process of collecting data about a target system, network, or organization. This data can include anything from IP addresses and domain names to employee names and email addresses. Essentially, it's the reconnaissance phase where we gather intelligence before launching any further attacks or defenses. Next, what is passive information gathering? This technique involves collecting data without directly interacting with the target. We'll explore various passive methods such as open source intelligence, which involve mining publicly available information from sources like social media, company websites, and public records. Next, what is active information gathering? Unlike passive methods, active techniques involve direct interaction with the target. We'll discuss methods such as port scanning, network mapping, and vulnerability scanning. Finally, we'll wrap up our session with a quick recap and summary. We'll highlight the key takeaways from today's tutorials and discuss how information gathering fits into the broader context of cybersecurity. So let's dive right in.
Welcome back. So as you saw in the intro, we are going to cover these following topics. We will start with what is information gathering. Then we will discuss passive information gathering, and there will be a demonstration tutorial as well. Then active information gathering. Then finally, we will recap and discuss what we did actually. So what is information gathering? Just to be sure that we are on the same page, okay? Information gathering actually is the understanding of the potential threats, okay? It's extremely important from three different perspectives. There could be more perspectives as well, but from three main perspectives that I consider very important, they are information gathering is extremely important. Okay, from cybersecurity perspective, let's say understanding the landscape of potential threats, enabling proactive defense measures. If I don't know the potential threats that I could face, for example, I would not be able to defend my network. Then it enables us to perform informed decision making. It helps us make informed decision making. Okay, so these are extremely important aspects in information gathering. And information gathering is also extremely important in reconnaissance. Okay, and what I mean by reconnaissance is like I can find, for example, I can gather the intelligence using OSINT tools, using uh, any tool, active tool, or for example, passive tool to find out about the potential target. Okay, and I can identify vulnerabilities and weaknesses as well. So in this way, we are actually able to map our potential attack surfaces. Okay. And information gathering is also extremely important from vulnerability assessment perspective as well. So it helps us in identifying and prioritizing vulnerabilities, okay, based on the risk level, the risk score associated with each of these vulnerabilities. And information gathering actually assists us in understanding potential attack vectors, okay. And it's extremely important to develop the mitigation strategies. Now, let's perform information gathering passively. So this is actually a hands-on tutorial, but before that, I would like to discuss here at least the definition of what passive information gathering is. Passive information gathering involves collecting data without directly interacting with the target system or entity. Okay, it could be anything, right? So it often relies on publicly available information, which is on you can find on the internet, for example, on company's website, on let's say university's website, or blogs, for example, any public source that you could find that information from. Okay, and these are some examples. So basically, who is lookup, for example, is a very basic tool that we use, for example, to retrieve information passively. PSF DNS, passive DNS, sorry, it collects DNS records, domain naming service that I mentioned earlier in other video as well. It records without directly querying DNS servers. So it doesn't leave any trace. Okay. And Google dorking, like you search, for example, on Google, for example, using different syntax, let's say. Okay, you can find different things like files, directories, vulnerability. So these are just the simple examples of this. Okay, so for example, when we start with who is lookup, okay, what does it do? What does this command do? Like who is, if we type who is example.com in Pali, what will happen? Okay, so ultimately, it will provide you the domain owner's identification. It will tell you about registration dates, and you will find more information as well. So, for example, outcome will be domain details, owner information, and what not, everything. So I will show you. I will show you. So here, for example, if I type this in Kali terminal, who is example.com, it will give me back the domain name, the registrar, okay, and the registrant name. Okay, so what will happen if you do, for example, who is, let's say, facebook.com, for example. Okay, we see it in a very quick. Okay, it's just a second. Welcome back. So as you saw in the intro, we are going to cover these following topics. We will start with what is information gathering. Then we will discuss passive information gathering, and there will be a demonstration tutorial as well. Then active information gathering. Then finally, we will recap and discuss what we did actually. So what is information gathering? Just to be sure that we are on the same page, okay? Information gathering actually is the understanding of the potential threats, okay? It's extremely important from three different perspectives. There could be more perspectives as well, but from three main perspectives that I consider very important, they are information gathering is extremely important. Okay, from cybersecurity perspective, let's say understanding the landscape of potential threats, enabling proactive defense measures. If I don't know the potential threats that I could face, for example, I would not be able to defend my network. Then it enables us to perform informed decision making. It helps us make informed decision making. Okay, so these are extremely important aspects in information gathering. And information gathering is also extremely important in reconnaissance. Okay, and what I mean by reconnaissance is like I can find, for example, I can gather the intelligence using OSINT tools, using any tool, active tool, or for example, passive tool to find out about the potential target. Okay, and I can identify vulnerabilities and weaknesses as well. So in this way, we are actually able to map our potential attack surfaces. Okay, and information gathering is also extremely important from vulnerability assessment perspective as well. So it helps us in identifying and prioritizing vulnerabilities, okay, based on the risk level, the risk score associated with each of these vulnerabilities. And information gathering actually assists us in understanding potential attack vectors, okay. And it's extremely important to develop the mitigation strategies. Now, let's perform information gathering passively. So this is actually a hands-on tutorial, but before that, I would like to discuss here at least the definition of what passive information gathering is. Passive information gathering involves collecting data without directly interacting with the target system or entity. Okay, it could be anything, right? So it often relies on publicly available information, which is on you can find on the internet, for example, on company's website, on let's say university's website, or blogs, for example, any public source that you could find that information from. Okay, and these are some examples. So basically, who is lookup, for example, is a very basic tool that we use, for example, to retrieve information passively. ESF DNS, passive DNS, sorry, it collects DNS records, domain naming service that I mentioned earlier in other video as well. It records without directly querying DNS servers. So it doesn't leave any trace. Okay. And Google dorking, like you search, for example, on Google, for example, using different syntax, let's say. Okay, you can find different things like files, directories, vulnerability. So these are just the simple examples of this. Let's go and check. So here, for example, on this Windows display, I show you here I have Kali. You, you have seen this Kali interface a lot of time. Here I have my presentation open, and this one is Ubuntu. Okay. Uh, so this setup you already know about these virtual machines. Now I need Kali and I want to demonstrate these commands, how to run these commands. Okay. So the purpose of whois lookup is to obtain domain registration information. So I mean, how, for example, we will see the outcome of this command. Okay, and it will show us, the domain owners, the registration dates, and there will be a lot of information that we can collect, for example. So then the syntax of this command is whoisexample.com. So here you can use, for example, any website that you want to get the who is lookup for. It could be a university. You can find, all these the websites of the universities, of different Amazon.com, for example, or any website. For example, I am here showing you about google.com, let's say, or facebook.com. So who is this? This is the syntax. I'm asking, for example, who is minus h, who is dot verisign jrs minus dot com, and about facebook.com. So let's check its output. Here, the output shows that domain name. So here you see what to do. For example, if you wrote this command, who is example.com, and you will get domain details. So this is your domain name, facebook.com, and registration owner information. So registry domain is like this one you can see, for example, and this is your who is server. Okay, and it has a registrar. Okay, and URL is this registrarsafe.com. Updated date, this is the date, for example, it was updated on, and the creation was like 26 years ago, for example, and registry expiry date is 2032. So you can find, different records for this who is lookup command. Okay, so this is how you can play with who is lookup. There are so many things. You can find different domain names as well. Like here you see, for example, for Facebook, you have domain status, client, delete, prohibited. Okay, yeah, registrar ID, INA ID is this. Lot of information. Name server, these are naming servers. Okay, DNS. Naming servers, a.ns.facebook.com. Another name server is b.ns.facebook.com. So you can find different domain owners, registration dates, and many more information about any domain that you are searching for using whoislookup. Similarly, if I do this for example, google.com, let's say, what can I find? Google.com. Okay. So google.com, here you see the database. Registry domain is this. Registry who is server? Yes, it is whois.markmonitor.com, and it has this website. You could go on this website and check what are the services provided by this website, for example. And it was updated on 2019, created on like 26 years ago, 27 years ago, and it is going to expire on 14th of September 2028. So like this, for example, you can find name servers, you can find registration, you can find expiry date, you can creation date, update date. So you can find a lot of information about any domain, okay, on this. Now, the next slide is, for example, discovering DNS records from a domain. So you will find these things a lot. If you find it will show you, it will tell you that it has a domain name. Okay, map domain names to IPv4 address. It's called a record actually. And 4 times this record shows IPv6 address. It maps domain name to IPv6. Then you have canonical name, CNAME it is called. We will see them in detail here. So there are like several tools, for example, I'm clearing it, the outcome now. So you can use, for example, just for an example, I have NSLOOKUP, dig, and host. Okay, these are different tools that you could look for DNS enumeration, okay, to find the records related to DNS. So the very first command is like host, for example. Okay, so if I use host command. Let's see what it prints, what it gives us. So basically, for me, the purpose of this command is to discover DNS records for a domain using the host command. Okay. So if I print host www.google.com, let's see what it comes up with. So www.google.com has address 2,216.216.58.204.132. So this host command gives me, for example, the the A record of IPv4. Okay, so it is mapping, this domain name www.google.com to IPv4 address, which is 216.58.204.132. Okay, and for example, it has IPv6 address of this one 2A00, for example. Okay, so if it had a mail server, it would have given us a mail server as well. We will discuss in detail. Now, for example, if I do it for Facebook, let's say, what it gives, facebook.com. So it should give me, yeah, you see here, it is an alias for a star mini facebook.com. Okay, so and it has IP address of 31.13.86.36. So here you have found another entry which is called alias, and the name of that server is this one, starmini.c10r.facebook. Fine. So we can find, for example, IP address related to a domain by using host command or by using simple ping command as well. Ping www.facebook.com, for example. But this will not give me IPv6 address. Sure. So, right. So you can get, for example, the IP address 31.13, which you got already here. Similarly, so we can find, for example, the IP address IPv4, IPv6 using host command, and also the alias if there is any with host command. Okay. Then we have NSLOOKUP. What this NSLOOKUP does? Okay, it gathers information about DNS records associated with a domain. And we will see, let's say we have been talking about google.com, let's say about facebook.com. Let's see if we get, if we do NSLOOKUP, what we get. Okay, so here you see it will be helping us to identify subdomains, mail servers, and other DNS related issues as well. Okay, details as well. You can simply write NSLOOKUP www.facebook.com. Let's say how the output looks like this. So NSLOOKUP www.facebook.com. Server here you can see is 192.168.1.1. This is actually my gateway, which is taking me out of my home to the internet, which connects me to the internet. And this one is the same server, but I'm connected on port number 53. Okay, so this is just how to interpret the outcome of this. Okay, and this is non-authoritative answer because I didn't get, the direct response from this server. Okay, so I am getting this information from my gateway, which actually knows about this server. Okay, so it is called non-authoritative answer. Here, yeah. So you can see, for example, this is more detailed output. So we have three main important points here. We got server information, which is DNS server. 192.168.1.1. This is my gateway. I would repeat it again. And it is connected on 53. It is getting, the response from 53 port, right? Then we have non-authoritative answer here. Okay, and it says it has a canonical name of this. It has star mini c. This one, like we already saw, for example, in the previous host command. And it has IP address of this 31.13.86.36. But who has written this record? Okay, so my server, my gateway knows actually this server is star.mini, and it has taken the response from it. And we have IPv6 address of 2A03, this one. Okay, so good, we are good. Then we have the output, for example, here you have seen server used for the lookup is 192 perfect, and the response was obtained from DNS cache or a secondary server. That is why it's called non-authoritative answer. So if it was authoritative answer, it would have directly come from this address. Okay. So the domain name is this, and it has a canonical name. Canonical name means it has an alias, okay, like you saw in the host command of star dash mini c10, like this. Now, this is IPv4 address that you are seeing here, 31.13.86.36, and this one is the IPv6 address of Facebook.com. Fine. So you can use, so we can simply use NSLOOKUP, we can use ping, we can use tracert, we can use, I mean, with tracert is not a passive command actually, but we can use different commands like dig, for example, also to find out about the DNS records. Okay. So next command is dig, yes. So the syntax of this command is same dig www.facebook.com. Let's see what it gives. So we need to understand this output, okay? So when we did dig www.facebook.com, okay, the output is comprising of four parts. So first part is global option, this one, okay, dig this, the journal information, I would say. Then we have opt sudo section, then we have answer section, and then you have all these details. So I have here extracted the extremely important information for you to understand this. Okay, so when you queried about this domain www.facebook.com, it showed no error. Okay, so here, for example, you see no error. So what does it mean? It means that it is up, it is not down. And this was the query that you sent, 36060. Okay, so here its query ID is this. Okay, and then the answer section, if you go into this section, these are different details of cookie, for example, and lot of things. But here in answer section is important. So you have this domain 343529, for example, is this, and you have the CNAME, canonical name that we were talking about. Okay, and then you have the IP address. And remember, I was saying like a record, for example. This record A shows you that it is mapping DNS mapping, sorry, IP address to domain name. Okay. Then in the query time says like only 20 milliseconds were used, for example, to get the reply. And we were using UDP. I showed you we were using 53, port number 53, which is actually UDP. Yeah, here it can be seen. Then we have, the time as well when we sent this query and we received size of the received message is 118 bytes. Fine. So this way, for example, we can understand different things. Similarly, we can exploit also DNS recon. So this DNS recon is also a very important tool. For example, if I clear it and if I clear it and yeah, let's just start, for example, DNS recon. So this command, for example, recon, if you do -h, you should be able to get the help. Okay, so what does it mean? It tells us that if we want to search for domain, okay, we need to add this -d switch. Okay, and if we want to do it for a particular range of IP, for example, we can do it. So here you can also find the different the explanation of all these switches, okay, or all these flags. So yeah, minus F, for example, filter out brute force domain lookups, minus A, perform AXFR with standard numeration. There are many things that you can explore. Okay, you can also write this output as a CSV file or as a JSON file or as a XML file, whatever way you would like to. You can also check the version of it, but I'm not sure if you need to install it. So if you find, for example, DNS reckon, if you don't find it on your tally, let's say, you are required to do only, sudo apt-get, sorry, sudo apt-get update or apt-get update, yes. So this command will update and then you need to install it, okay? Sudo apt-get install this DNS recon, so it will be fine. But suppose you have this, so then, for example, DNS recon, and it should give me, if I do minus D, means I'm searching for a domain, and domain name is this, www.facebook.com. Just giving you an example, okay? Sorry, yeah, here, for example, with DNS recon, you can see that we have, uh, you know, we have got this output, and it is saying DNSSEC is not configured for this www.facebook.com. It's perfectly fine, but we can find different records like here start of authority SOA, okay, and SOA has this IP address 129.34 134.30.12, and it has a record. This is a sorry, IPv6 address of this SOA authority. Then this canonical name we already found from other commands like dig and like from host. And then we have here the IP address of this canonical server, and we have AAA record, okay, and we have this one as well. It is called SFS record, and no service records found for www.facebook.com. Okay, so the point here is by using this command, okay, we have identified the start of authority SOA server. Okay, we have the canonical name of this server. Okay, and we have IP address of this server. Okay, this one 31.13, and we have SFS records as well. So this way we can play with DNS records, for example, and we can get the information we want, right? So these three, four methods that I showed you, host, dig, NSLOOKUP, DNS reckon, for example, or there are other tools as well. I leave those tools for your assignment. For example, you can use Multigo, you can use Shodan, for example. They are GUI based tools, actually, you could use them. And now we are moving to information gathering, but with, I mean, actively. Okay, what active means? We are going to, we are going to gather this information by probing our target system, okay, or a network and collect data. So it means we will leave our traces while doing so. Okay. So here, for example, I would like to request you to get a permission if you want to scan or you want to get to perform active information gathering for a company. But that's why what I have already proposed is create your own, for example, testing lab like I have created, and play with your own devices, play with your own machines, for example. So I have here with Ubuntu as well. I have another virtual machine as well, which I call Metasploitable. Uh, and I can, for this active information gathering tool, for example, I can try with my internal network. Okay. So I'm clearing it now, and now we have so many methods. For example, we have so many tools that we could exploit for active information gathering, like Nmap, network mapper, for example. Okay, and its purpose is to find network scanning and host discovery. It will scan, the target system. I can just give you an example. So here, for example, if I write Nmap, um, yeah, if you want to take help, for example, you can simply go with this H, and it will give you a lot of options you can play with it. Okay, so clearing it again, I'm just want to show you how it works. So nmap minus H, nmap is space. Let's say if I do minus O, I will tell you later, but okay, at this stage I can tell you that this minus O will give me, the operating system of my target machine. Okay, so here, for example, my target machine is 192.168.54.3. Mind you, this is the IP address of my metasploitable. Okay, so when I do this, for example, it it sorry, it requires root privileges, so I need to do sudo nmap minus o and 3, my password, and here you see the scanning has started and nmap scan report for this machine. Host is up, fine, and all 100, or sorry, 1000 ports were scanned and they are in ignored states. We will discuss these ignored states in scanning in the next lab, for example, that I'm planning to conduct. And here we have 1000 closed TCP ports. The MAC address of that machine is this. And here, too many fingerprints match the source to give specific OS details. What does it mean? It performed this. And yeah, just a second. Let's go with 4 because it's this Ubuntu actually. It doesn't have a vulnerability. So you see here, it has all in ignored states, but that's why we have metasploitable. No, so metasploitable is a intentionally made vulnerable machine. So if you click this, if you .4 for example, if you type this command, what it will do, it will give us the details of all these ports plus operating system. So here you see Linux 2.6.6 is running on that machine, and OS kernel is 2.6, and this is actually these are the OS details, and network distance is just one hop away. So I'm directly connected to this machine. Okay, and here all these ports you see here, they are open. So we will play with these nmap, especially. I want to create a complete lib using nmap. Okay, so here I'm clearing it again. So this way, for example, you can understand different vulnerabilities, different things about your target. Like we saw, for example, which operating system is installed on our target machine. And we saw different ports that were open as well. Okay. Similarly, we can use hping command. It is also, active information gathering tool, and you can play with this hping 3, for example. And so here you see hping 3, it will ping actually the target IP. So, and minus C, I have already told you about this. So minus 3 means it counts 3. It will send 3 packets, for example. Port number 80 on minus P is the another, for example, flag. Port number 80, and here it will give you the IP that you will get. Okay, so if you want, for example, hping 3 faster, so I have added this faster because it's a bit slow. And 4, for example, if you want me to do this minus P as well, I will do minus P 80, and operation not permitted, I need to do sudo. Okay, so here you see no flags are set. 40 headers, hping 192.168.50.4.3. It actually is a slow command, so but useful. I'm stopping it just to save the time. You see here we have a lot of output. Okay, Control C, clear, and because I didn't give this minus C3, so it just busted, a lot of traffic to the target machine. Similarly, we have netcat as well. You can use multiple tools. Okay, but apart from these example tools that you can play with, for example, uh, I showed you here nmap, hping, netcat. We can discuss these in the next slide, in the next video as well. There are other tools as well. For example, net discover. Okay, so if I want to discover my network, identify the live hosts, for example, the hosts that are up, the hosts that are down, for example. Okay, I will be able to, I can use net discover to do so. So if I do net discover here, for example, and basically 192.168.54.0/24. I'm on this network actually, and you can check -r. What does this mean? It is a range of IP addresses. Okay, so even you sorry, I need to use sudo. Okay, so here it has started, and what it will do, it from this pool 192.168.54.0, for example, /24, what it will do, it will send pings to every device, every machine. Okay, and based on the reply, it will come up with the the decision that okay, these things are up and these are not up. Okay, so here, for example, if I click Control C, why it didn't capture, I really don't know. Let me see. Let me do it again for another IP address. Let's say 10.0.2. So this interface is a NAT interface connected with the internet. If I do this for this IP address range, for example, let's see what it happens. Yeah, so it finds something, and here you see you have three IP addresses. Okay, three machines in running condition. One 10.0.2.1 is the IP address of this Kali, the IP address of the gateway that connects Kali to the internet. And this two, for example, I don't know. And 10.2.3, I don't know. We can search. Okay. So if I do route minus n, for example, enter. So here you see this 10.0.2.1 is my gateway, and I'm connected on this network 10.0.2.0. The subnet mask of this is 255.255.255.0. Also, I'm connected on this, for example, Ethernet 0, Ethernet 1 to this network 192, where I have Ubuntu and Metasploitable connected. Okay, but it was taking longer, so I did this. I used this network to scan it. Clear? Now we have similarly WhatWeb. WhatWeb is a very powerful web scanner. Okay, there is another called DIRB as well. Maybe if I check DIRB, yes, there are many. So DIRB, for example, if I search, do this information for 192.168.54.4, for example, this is my Metasploitable. So here you see what is it doing. This DIRB is scanning for vulnerabilities on this machine. And what is it doing? For example, it is checking every directory, every folder, every node, for example, in that particular directories, every file, and it will come up with a detailed report. This report, you can simply write this report as well using simple command. I can tell you. So here, Control Z, I stopped it here. And if you, for example, here write, let's say, dirb space 192, we can take the help as well. Dirb minus h, sorry, dirb manual, dirb. Just a second. Yeah, this one. So with dirb, for example, you see, dirb is a web content scanner. It looks for existing web objects. It basically work by launching attacks, dictionary based attack against a web server and analyzing the response. Okay, so it's a very powerful tool that you could use. And here -v shows you non-existent pages. There are many flags that you could search, you could play with, for example. So you can search with for headers, you can search for use case sensitive, insensitive search, for example, location as well. There -l, you will find where this server is located, for example. Output file, there are many things that you can explore. Username, -v show not existing pages, and also like you can save this output as well as a text file, for example, or okay. So clear. Similarly, I will tell you here how to write this code. So now let's say what web. Okay, what web, and if I do this 192.168.54.4. This is again the IP address of my metasploitable. If I click this, what is it doing? It is similar to div. It is scanning, the web. Okay, and it will identify all the technologies being used and the information about the version and potential vulnerabilities. Okay, so here you can see yeah, this is TCP, this is HTTP header 200. Okay, it means we have received the response. Country is reserved, it's not explained. And HTTP server is Ubuntu, Linux, Apache is installed. And there are its title is meta exploitable. So a lot of information is written. So if you just want to use, for example, -v, what it will do, it will make this readable. Okay. So if you click -v, you see now it's better readable. So here the Apache is installed. The Apache is you can read, for example, the version as well. Okay, which version of Apache is installed, and HTTP server has Ubuntu Linux installed, and it has this server string. Similarly, PHP is installed on this, okay, and web-based distributed authoring and versioning, a lot of things you can find, and this is HTTP header that, for example, you managed to send, okay. So I'm clearing it again, okay. Similarly, you can use a lot of tool with, for example, what web if I want to, because you know if I want to actively gather information about some domain, for example, let's say www dot let's say unity.it. So this is a, university in Trento. If I check this, and sorry, if I do this -v so that it should be readable, or for any university that I would like to search for. It will take some time, but this way we can perform this what we have, vulnerability scanning. There are different aggression levels for this. Okay, so say it's forbidden, and we were unable to get a lot of information about it. But if we search for other university, let's say from Pakistan, KFUIT, actually this university I have worked for, so I think they will not kill me. www.kfueit.edu.pk. I'm searching for it. Let's see. So, but here you see I have found the IP address of that machine. Okay. So, is it still scanning? Yes, HTTP server. So we have found this. You see, a summary HTTP server, and this server, for example, is has 1.1.8.1 installed. Redirect location, there is some redirection look is also scanned is there as well. So HTTP server, we can find the operating systems and everything about different server, and IP address is returned, and the country is Pakistan. Okay, so we have managed to get some information. Okay, and yeah, and we have another web page here, for example, and we can play with this using different what web switches. Okay, so here a lot of things we have obtained, IP addresses and the summary as well for all the servers that are connected, and to be honest, a lot of information. Okay, so similarly we can exploit what web as well, but potentially please use this for to explore metasploit. Then we have mass scan. Okay, says this mass scan is also a high-speed TCP port scanner. Okay, so it searches for TCP ports, for example, and if they are open or not. So it is designed to scan the entire internet as fast as possible, allowing researchers to quickly identify open ports and potential vulnerabilities across a wide range of ports. So here I'm trying to use mass scan, let's say, but for -p one to not you know scanning all 65,000 ports, but just 1,000 ports, and of what of this metasploitable. Okay, 168.54.4. Let's see, mission denied. I need to put sudo. Yeah, so discovered port number 25 open, okay, and port number 23 also open, port number 445 also open. So most of the TCP ports are open, okay, and yeah, so all these ports are open, which actually could lead to hijacking, to hacking this machine. We will do this hacking in the next lab, okay. So and Wireshark, if you have not seen the previous video, please go and check this Wireshark. I have, tried to explain how Wireshark could be used to capture traffic, for example, and different packets. And from packets, you can learn, different IP addresses, MAC addresses of the machines, about different protocols, different IPs, for example. Okay, so Wireshark, I assume you have already covered. Then another tool is burp suite. Okay, so burp suite is extremely important tool. It can capture, you can try to capture all the traffic between you and your web server, between the host and the target machine and the web server. Okay, so burp suite is an extremely useful proxy machine that you can capture the traffic between those two machines, and you can do redirection, you can do injection, whatever. And this tool also you could use, for example, to hack someone's computer. Control Z, and this one also, like, I don't think it's yeah, I can show you very very quickly. Just I make it big. So here, for example, what I have done is I have opened www.unibis.it. So this is the page of Unibis, okay, on Firefox. And here you see I have received, this is the request that I sent, and its reply should be the response. So this is the response, and so you see here you have, you know, the headers of all these HTTP. So we can discuss this HTTP version 1.1 or 2 later, maybe in the upcoming videos. But here, for example, you can see that we have captured the HTTP packet, which was supposed to be received by the client. Okay, so this way you can play with this burp suite as well. Burp suite is also used to capture packets exactly like Wireshark is used to. Okay, so here, yeah, here. Okay, so now similarly, Metasploit framework. Okay, so Metasploit framework is also used for active information gathering. It is also called a penetration testing and exploitation framework. Okay, identify vulnerabilities and launch attacks. Okay, we can use it for, and you need to use this MSF console. We will discuss this in the next lab, which will be about scanning and about penetration testing. Okay, and the harvester is also an extremely important tool. Okay, and it's an open source tool actually. So like if I here for example, the harvester minus D, which is the domain 192.168.54.4, for example. And if I do this, what it will give me, like, because it's a meta exploitable machine, okay, it didn't give anything. But if I search for a university, let's say here, the harvester here, for example, this iobm.edu.pk is also another university in Pakistan. If I do this minus B means which and space Google, for example, we can play with this. The harvester, yeah, sorry, you can you can play with these switches. So this domain is simply www.iobm.pk, edu.pk, and minus B means the search engine where I'm going to search, and all means everything, Google, whatever social sites are available. So if you click this, for example, it should bring me some information. Let's see what it brings. It may take some time. So it's searching on Bing, it's searching on Anubis, for example, and got more than 8190 bytes. Okay, problem. No problem. Here is dumper, it is searched as well. Okay, and an exception has occurred. Blah blah. These are different warnings that you could simply ignore. But it is searching on, hacker target because we have added this all as a switch. For example, it is searching for everything. But you can, limit this search to only Google. If you had applied Google, for example, you could have got only Google. Okay, so maybe it is taking longer, but it will return you some information. This is 100% sure. Okay, yeah. So here, for example, the outcome you could see here. Okay, so it managed to find some websites, IPs. So you see here three IPs, 192 something. If I need to make it big, for example, here it has found these IPs 202.69.33.203.54. These are the different IPs that it has found. And the most important thing is it has found a lot of email addresses. So here you see academics at IOBM, admissions, Asad.Hussain. So from here I can actually find the individual targets as well. So Asma Rahman, all these Ikhlaq, Shiraz.Hamid. Now if I take this name and search it on the internet, for example, I'll be able to find the details of this person, for example, for a targeted attack. So, good. And here, yes. So, it is still running, so I want to stop it now. Clear. And then we have ReconNG, Web Reconnaissance Framework, okay? You can also use this recon ng, for example, for reconnaissance framework. It's a reconnaissance framework, and you can play with as well. So it's simply, you need to use recon. Then we have nmap. I told you that this is an active scanning tool, network mapper. We could use, for example, we already used -O for operating system finding, and we managed to find the operating system of meta-exploitable. Okay, but there are very a long list of commands that you could use. For example, if I use nmap help manual, for example, manual nmap. So you should be able to see here the purpose of this nmap is an open source tool for network exploration and security auditing. So the output from nmap is a list of scanned targets with supplemental information on each lot of information. Okay. And here, there you will find different switches. So here, one more thing I would like to add is you can use nmap for for stealth scanning as well. What I mean by stealth scanning, so we are talking about active information gathering, right? So what does it mean? It means that all these traces that we are doing, for example, these traces are saved from the server's logs. They can find who pinged those machines or who got the information. Okay, but if you use nmap in stealth mode -ss, for example, switch, you their server will not be able to record. Okay, so there are different things that we could play with it. So here it's example, if you see a representative nmap scan nmap -a. So this switch, for example, -a scanme.nmap.org T4. This is the report. Host is up. DNS record is this IP address, and it's make it this name service, and 999 5 closed ports. TCP is open because most of our you know in remote work, we always have to keep this port open. And this operating system has 2.6, for example, this is a complete scan, for example. So I can show you here, for example, what is this, uh, what are these switches for? So if you find SP, small s and T, okay, host recovery, yes, here you see SN, SPPA, PU, PV, PE, S minus ST. basics, okay, scanning techniques, minus ST here. So TCP connect scan is the default TCP scan type when sync scan is not an option. This is the case where when a user, for example, here, when a user does not have raw packet privileges, instead of writing raw packets as most other scan types do, and may ask the underlying operating system to establish a connection with the target machine and port by issuing the connect system. So you see here, there are many techniques, for example, that we can play with. And there are many scanning techniques, SU, all the UDP ports you could scan, for example. And you have this SY, SCTP is a relatively new alternative to the TCP and UDP protocols, combining mostly TCP and UDP and also adding new features. I would suggest you to play with this to check, all these things. With window scan, with acknowledgement scan, and SM, lot of things. And the very good thing is you can write, all these, all this report, okay, and OS detection minus O we already tried, for example. Again, I would say there is a lot of content that we could explore, okay? So, okay, so here we are. Then we have, there are so many commands that you could play, for example, with. And then HPing we already checked. No need to repeat this again. And Netcat also is a network utility for reading, writing data across different networks. It also performs port scanning, banner grabbing, and creating, for example, reverse shells as well. So these are the very important utilities that you could play, for example, with. So here, just giving you an example, connection refused minus V. So connection refused, yeah. So not just one more try, 192.160 minus V is simply for verbose output. Inverse host lookup failed, unknown host, no ports to connect to, yeah, 22, let's say. So you see here, it's trying to connect to this machine, which is our Ubuntu, okay? Because the port 22 was open, that's why. Now, finally, Control Z, finally, we have DNS twist as well. So this DNS twist also detect squatting, phishing, and brand impersonation, generate domain variations, and check their availability. This is also a very important tool that we could play, for example, with. Okay, so clearing it again. DNS twist, if we do it for Facebook.com, for example, let's see what it brings up with. So it will take a lot of time because it has started 6 scanner threads and 20% of this found ETA, speed. So it's actually performing DNS uh, record information, okay? Identifying threads and similar domains. I'm stopping it here. I don't want to be caught by Facebook. Clear. And here, for example, if we do here the same for meta-exploitable. Let's see if it is runnable or not. 54.4, for example. Yeah, so it's not a domain, to be honest, yes. But maybe here I did this for you. So here you see there is a lot of information that we got, okay? So about, you see here, there are so many IP addresses. This MX, this record for MX I was talking about, you remember? So this MX, for example, here, MX. Yeah, this one. So MX is a mail exchange record. It will provide you the record for mail servers of this domain, right? So yeah, here. So I would say practice makes you better. Practice is always important. So just to with this demonstration, we have reached the end of this presentation, and just to quickly recap what we did. We started our discussion with information gathering. What is information gathering and why is it important? If you have not yet seen that previous video on information gathering, I would strongly suggest to go on this video and check. And I have discussed all these details there as well, but this is a practical demonstration, so I cannot repeat everything. And here we discussed, the why passive information is important. Passive information gathering is important, okay? And we discussed different tools, for example, to gather passive information. We also discussed, different tools for active information gathering as well. Multiple tools we saw, Dentist we saw WhatWeb, we saw DIRB, we saw DNS, NS lookup. For example, we checked a lot of things, okay? So with this, I think we are done with this video. I hope you will find this video interesting and useful. If you have any questions, just leave me, your questions in my comments. I will try to answer each of those questions. And if you like this video, like the information in this video, please like this video, share and subscribe. Share this video to your friends and subscribe to this channel. I appreciate it a lot. Thank you so much. And until next time, bye.